Hey everybody, welcome. Thanks for joining. So maybe some of you were at the live stream with the version 1, but I feel like I improved version 2 with a lot of cool features. So version 1 was pretty much just for the purpose of live streaming educational content, but version 2 actually builds an entire website. So you can use it to stream, for example, such as I'm going to be doing here in a moment. But at the end of the stream, you'll have an entire website that you can deploy. I have actually deployed it at Railway. So this Python course, full Python course is actually live online. And as you can see, I can check out its chapters.
Classes and objects. In Python,
and the audio will start playing. You can play or pause the audio.
Blueprints for attributes and
so yeah, this is deployed. So I'll talk about some of the new features and I'll start the live stream, auto streamer, and then at the end I'll come back and I'll actually deploy it. Let me show again. See, as you can see,
package management.
This is a full Python course deployed currently online. The link is in the description if you want to check it out. So the new features are as follows. There's now a dark theme and light theme. What we just saw was light theme. I added fast course generation without audio playback. It's false by default. So the audio will play. Oh, thank you, Scott. Appreciate it. And if you say when this is false, like it's kind of like in a streaming mode, right? So it will live stream the course with the audio, but at the same time generating the website. But the audio playing takes some time. So if you didn't intend to stream, right, to YouTube or Twitch, you can actually set this to true so that your website generation will go faster. You can also set a style. This is like a style of conversation. You can set it like, explain it like to a 10-year-old or explain it like a pirate. You can also set a custom start. I created a longer Python curriculum. So you can enter any one of these topics, as you see. For example, dictionary data structure, anything you see in the topic into a custom start. So it'll pick up right there. Okay. But it will recreate a new website. So this is probably good for streaming purposes. So just in case if you're streaming and something happens, maybe API is returning error or something, it usually should recuperate itself. But if it doesn't, then you can set a custom start. Just make sure to check where the stream failed. And you can restart it from that point. So it'll create a website, and then at the end of the course generation, it'll actually copy it to its own folder. Here, like I created a Numpy course, for example. So it's pretty cool. We'll get it running. It has light mode and dark mode. You'd have to decide on it ahead of time, though. And the word limit is more or less an instruction to GPT on how long you want the responses to be. I find 100 to be a good place. Actually, Scott, in the version 1, you can also set custom start, but it's actually done, I believe, by indexing. So that's more difficult. So this is much more self-explanatory. So 100 words is about pretty good. It generates content, so as you see here.
Context map.
It's pretty concise.
Testing with
it's on the screen pretty well. So let's go ahead and start it. If you have any questions, I'll be in the chat. And at the end of the course, I'll come back. At the end of the stream, I'll come back and we'll deploy this. I'll show you how to do it with Railway, but I'll be updating this particular one because this one's going to be a longer Python course. It's a lot of fun to learn this way, I find. I actually learned quite a lot about Python that I didn't know before. Without further ado, let's go ahead and start it. Before I do, there's a curriculum maker, okay, which you can use to create curriculums. And then after that, you run AutoStreamer version 2.py, and it'll ask you which curriculum you want to start with. I'm going to select Python. So I'm going to select 3. So now it's starting up. You do have to select index.html and start it with live server, which I have already done. So shortly, the audio should begin, and this website should refresh. If not, I'm going to refresh it myself, and then the auto streamer will take over. But again, I'll be in the chat. If you have any questions?
History of Python.
And
Before
it has
diving into
started,
Python
and
code,
the download
it's
link
important
is in
to
the
understand its
description as
origins.
well. Hey, Xavier.
Python was conceived in the late 1980s by Guido van Rossum at Centrum Wiskunde en Informatica, C2I, in the Netherlands. The implementation of Python was started in December 1989 and officially released to the public as Python 0.9.0 in February 1991. The code shown is a traditional first program that many beginners write when learning a new programming language. It demonstrates how to output a string to the console in Python. This code, while simple, embodies the readability and ease of use that Python was designed to provide. The history of Python is a story about making programming more accessible and fun, which is reflected even in such basic examples of Python code. Python 2 versus Python 3. Python 2 and Python 3 are two major versions of the Python programming language. Python 2 was released in 2000, and Python 3, which is not backward compatible with Python 2, was released in 2008. The Python community ended support for Python 2 in 2020, which means there are no more updates, not even for security vulnerabilities. The code shows a basic print statement in both Python 2 and Python 3. In Python 2, the print statement does not require parentheses. However, in Python 3, the print statement is actually a function that requires its arguments to be enclosed in parentheses. This is one of the most noticeable syntactical differences between the versions, and a simple example of Python 2 code that will raise a syntax error in Python 3. Installation and environment setup. Before you start coding in Python, you need to install the Python interpreter on your computer. You also need to familiarize yourself with the environment where you will write and execute your Python code. There's no specific code for installation. Instead, you typically download the latest version of Python from the official website, python.org. After downloading, you run the installer specific to your operating system: Windows, macOS, Linux, Unix. During installation, be sure to check the option to add Python to path to ensure that the interpreter can be easily accessed from the command line. Once Python is installed, you can verify the installation by opening a terminal or command prompt and typing python-sh version, which should display the installed Python version. Interactive Python REPL. REPL stands for Read Eval Print Loop, and it's an interactive prompt that Python provides for testing and experimenting with code snippets. It reads your input, evaluates it, prints the result, and then loops back to read the next input. In the provided code example, the REPL reads the command print hello world, evaluates it by executing the print function, outputs the string hello world to the screen, and waits for the next input. Running Python scripts. To run Python scripts, you need to have...
I just want to say, you can actually click F11 and make it full screen.
Bottom. This code displays the message hello world to the screen. It's the most basic Python script. To run it, save the code in a file with a .py extension. Open a console window, navigate to the files directory, and type python filename.py. If you're using Python 3, you might need to use Python 3 filename.py instead, depending on your system configuration. Basic syntax and execution flow. Python syntax refers to the set of rules that defines how a Python program should be written. Execution flow describes the order in which the code is executed. Python follows a top-down approach, executing code from the first line to the last line, unless it encounters control flow statements like loops and conditionals, which can change the order of execution. The code snippet defines a variable x and prints a message before entering a conditional statement, an if-else block. The condition x10 checks whether x is greater than 10. If it's true, x is greater than 10 is printed. Otherwise, x is less or equal to 10 is printed. The execution flow then continues to print after conditional after exiting the if-else block. Python keywords and identifiers. In Python, keywords are reserved words that have a specific meaning and purpose in the language. They cannot be used as identifiers, which are names given to entities like variables, functions, or classes. The code imports the keyword module, which provides access to Python's reserved keywords. It then prints out the list of all keywords in Python. These keywords cannot be used as variable names, function names, or any other identifiers. Lines and indentation. Python uses indentation to define blocks of code. Unlike other languages that use symbols like braces, Python uses the indentation level to determine the grouping of statements. In this code, the if statement has a block of code underneath it that's indented with 4 spaces. This is a standard indentation level in Python, though tabs or a different number of spaces can be used, as long as the usage is consistent. The else clause is aligned with the if start, indicating that it's a separate block at the same level of logic, and the line beneath it is indented to show that it belongs to the else block. Incorrect indentation will lead to indentation error in Python. Comments and documentation. In Python, comments are used to make the code more readable and to provide explanations about the code, but they are not executed by the Python interpreter. Documentation using docstrings provides a convenient way of associating documentation with Python modules, functions, classes, and methods. The shack symbol is used for single-line comments. Everything following the shack on that line is ignored by the interpreter. The triple quotes are used to define a block of a docstring which can span multiple lines. This docstring explains what the enclosed function, method, class, or module does. The pass statement is a placeholder indicating where code will eventually go. It does nothing when executed. Numbers int, float, complex. In Python, numeric data types include integers, floating point numbers, and complex numbers. Integers, int, are whole numbers, floats, float, are numbers with a decimal point, and complex numbers, complex, have a real and imaginary part, written as a plus bj, where a is the real part and b is the imaginary part multiplied by the imaginary unit j. The code defines 3 variables, int number as an integer with the value 42, float number as a floating point number with the value 3.14, and complex number as a complex number with the real part 1 and imaginary part 5. The type function is used to print the data type of each variable. Running the code will output class int, class float, and class complex, confirming their respective data types. Boolean type. In Python, the Boolean type is a data type that can take on 2 values, true or false. These are the only Boolean values, and they are used to represent the truth value of expressions. The Python type for a Boolean is bool. Boolean values are often the result of comparison and logical operations, and they are especially useful in control structures such as if statements and loops. In the code, variable a is assigned the Boolean value true, and variable b is assigned the Boolean value false. The result variable demonstrates a comparison operation, 10, 9, which evaluates to true because 10 is indeed greater than 9. The AND operation variable demonstrates the logical AND operation, where the result is true only if both operands, a and b, are true, which in this case is false. The OR operation variable shows the logical OR operation, which is true if at least one of the operands is true. The NOT operation is a logical NOT operation, which inverts the Boolean value of a from true to false. Strings. In Python, strings are sequences of characters used to store text. They are enclosed in quotes, which can be single, double, or triple for multi-line strings. Strings are immutable, meaning once created, they cannot be changed. This code defines a string variable greeting with the text, hello world. It prints the 8th character, W, index starts at 0. Then it converts the string to uppercase using the .upper method and prints the result. String operations and methods. Python provides several operations and methods for strings, allowing for powerful and efficient text manipulation. Here we will look at basic operations like concatenation and methods such as upper, lower, replace, and find. The code snippet demonstrates basic string operations and methods in Python. The plus operator concatenates hello and world with a space in between to form hello world. The method upper converts the string to uppercase, lower to lowercase. Replace switches world with Python in the string. Find returns the starting index of the substring world in the combined string, or -1 if not found. List data structure. In Python, a list is a mutable, ordered sequence of items. Lists are versatile and can contain items of different data types, including other lists. They are defined by enclosing items in square brackets, with each item separated by a comma. The provided code defines a list sample list with a mix of integers, strings, a float, a nested list, and a boolean. It then prints the second item, Python, using indexing at position 1. After that, new item is appended to the end of the list. The last element appended is accessed using negative indexing, -1, which is new item. Finally, the code modifies the first element of the list by setting the value at index 0 to 100. The entire updated list is then printed. List operations and methods. In Python, lists are versatile data structures that can hold items of different data types. They are mutable, allowing modifications after creation. Let's explore some common list operations and methods. This code snippet demonstrates how to perform various operations on a list in Python. We append and extend the list with new elements, insert a specific element at a given index, and remove elements by value or index. We retrieve the index of an element, count how many times an item appears in the list, and sort or reverse the list in place. Lastly, we create a copy of the list. Each of these operations mutates the original list, except for making a copy, which creates a new list. Tuple data structure. A tuple is a collection which is ordered and unchangeable. Tuples are written with round brackets and can hold a mix of different data types. The code defines a tuple named example tuple with an integer, a string, and a float as elements. The first print statement outputs the entire tuple, while the second print statement demonstrates accessing an element by index, which returns apple. Set data structure. A set is an unordered collection of unique elements in Python. Sets are mutable and can be used to perform mathematical set operations like union, intersection, difference, and symmetric difference. This code snippet demonstrates the creation of a set with 3 unique elements 1, 2, and 3. The add method is used to insert a new element 4 into the set. Since sets are unordered, the order of elements when printed can vary. Then the discard method is used to remove the element 2 from the set. Attempting to remove an element that is not in the set does not raise an error. Dictionary data structure. In Python, a dictionary is a versatile and widely used data structure that allows you to store key-value pairs. Each key must be unique and immutable, often strings or tuples, while values can be of any data type. Dictionaries are unordered collections, which means the items do not have a fixed position. Python dictionaries are optimized for retrieving data when you know the key. Here's how to define and use a dictionary. This code snippet illustrates several common dictionary operations in Python. A dictionary named person is created with keys name, age, and email. The value associated with the key name is retrieved using square brackets, while the value for age is accessed using the get method, which is safer as it returns none if the key does not exist, rather than raising a key error. The email address is then updated by assigning a new value to the email key. A new key-value pair, city, New York, is added. Finally, the key age and its associated value are removed using the del statement. Mutable versus immutable. In Python, data types are either mutable or immutable. Mutable objects can be changed after they are created, while immutable objects cannot be altered. Understanding the difference is important for avoiding unintended side effects in your code. The code attempts to change the first character of an immutable string, which raises a type error, demonstrating the immutable nature of strings. Then it changes the first item of a list, which is a mutable type, and prints the modified list. This emphasizes that lists allow in-place modification, highlighting the key difference between mutable and immutable types. Type conversion and casting. In Python, type conversion, or type casting, is the process of converting one data type into another. This can happen implicitly or explicitly. Implicit conversion doesn't need any user involvement, and Python automatically converts one data type to another, if necessary. Explicit conversion must be done manually by the programmer, using conversion functions like int, float, star, etc. Here's a simple example to demonstrate explicit type conversion. In the code sample provided, we start with number string, a variable containing the string 5. We want to perform arithmetic operations on it, which we can't do while it's a string. So we use int to explicitly convert it into an integer. The result is stored in converted number. When we print converted number SAR2, it outputs 10 because converted number is now an integer, and we can multiply it by 2. Had we not converted number string to an integer, multiplying it by 2 would have resulted in the string 55 string concatenation, rather than the mathematical result 10. Arithmetic operators. Arithmetic operators are symbols that represent computation between variables and/or values. The basic arithmetic operators in Python are addition, plus, subtraction, minus, multiplication, SLOR, division, slashed, modulus, cent, which gives the remainder of a division, and exponentiation, store. The variables a and b are assigned the values 10 and 3, respectively. The addition variable will yield 13 because 10 plus 3 equals 13. Subtraction results in 7, as 10 minus 3 equals 7. Multiplication results in 30. Division results in approximately 3.3333 because it divides 10 by 3. Floor division results in 3 because it divides 10 by 3 and rounds down to the nearest whole number. Modulus results in 1 since it's the remainder of 10 divided by 3. Exponentiation results in 1000 as it's 10 raised to the power of 3. Comparison operators. Comparison operators in Python are used to compare the value of two operands. They evaluate to true or false depending on the condition. The standard comparison operators in Python are equal to, not equal to, less than, and greater than, less than or equal to, and equal, greater than or equal to. The code snippet demonstrates the use of comparison operators by comparing two variables a and b. It results in Boolean values. Is equal checks if a is equal to b. Is not equal checks if a is not equal to b. Is less checks if a is less than b. Is greater checks if a is greater than b. Is less equal checks if a is less than or equal to b. And is greater equal checks if a is greater than or equal to b. Logical operators. Logical operators in Python are used to combine the conditions. They include and, or, and not. The AND operator returns true if both conditions are true. The OR operator returns true if at least one condition is true. The NOT operator inverts the Boolean value of the condition that follows it. In the code, A is true and B is false. Using AND, C becomes false because both A and B are not true. B is false. Using OR, D becomes true because at least one of A or B is true. A is true. Using NOT, E becomes false because it inverts the true value of A. Bitwise operators. In Python, bitwise operators are used to perform bit-level operations on integers. The integers are first converted into binary, and then operations are performed on each bit. The AND operator AND takes 2 bits and returns 1 only if both bits are 1. The OR operator returns 1 if either or both bits are 1. The XOR operator SQUED returns 1 only if the 2 bits are different. The NOT operator SHIFT inverts the bits, producing the 2's complement of the number. The left shift operator, AN, shifts the bits to the left by the specified number of places, effectively multiplying by 2 for each shift. The right shift operator shifts the bits to the right, which is like dividing by 2 for each shift, rounding down. Membership operators. In Python, membership operators are used to test whether a value or variable is found in a sequence, string, list, tuple, set, and dictionary. There are 2 membership operators explained below. In and not in. The in operator returns true if the value is found in the sequence, and not in returns true if the value is not found in the sequence. The code defines a list of fruits. It then uses the in operator to check if banana is in the list of fruits, which returns true. The same operator is used to check if pear is part of the list, which returns false, because pear is not in the list. The not in operator checks if apple is not in the fruits list, which returns false because apple is in the fruits list. The last line uses not in to verify watermelon is not in the list, which returns true. Identity operators. Identity operators in Python are used to determine whether 2 variables are the same object. The 2 identity operators are is and is not. They are used to compare the memory locations of 2 objects. In the given code, A and B are initialized with the same integer value 10. Since integers are immutable, and Python optimizes resource usage by reusing the same object for small integers, which includes 10. A and B actually reference the same object in memory. Therefore, A is B returns true. Similarly, C is assigned the value of B, making C and B refer to the same object, so both A is C and B is not C evaluate as true and false respectively. The if statement. The if statement is used to test a specific condition and execute a block of code only when the condition is true. It's the most basic of the control flow statements and enables conditional execution of code segments. In the code provided, x is a variable that is being checked to see if it is greater than 0. If this condition, x-0, evaluates to true, then the code within the indented block after the if statement will execute, and x is positive, will be printed to the console. If x is less than or equal to 0, the indented block will not execute, and nothing will be printed. The elif clause. In Python, the elif keyword is short for else if. It allows us to check for multiple expressions and execute a block of code as soon as one of the conditions evaluates to true. If the condition for an if statement is false, the elif clause is checked, and so on. If none of the if or elif conditions are true, an else clause can be used as a final default action. In the provided code snippet, we are evaluating the value of the variable number. When the if condition number 10 is evaluated, it is not met because number is 35. The program then moves to the first elif clause. It checks whether number 20 is true, which is also false. The process continues with the next elif, number 30, which is again false. Finally, since none of the previous conditions were met, the else block is executed, and 30 or more is printed to the output. The else clause. In Python, the else clause can be used with loops, for or while. Traditionally, an else clause is associated with an if statement, but when paired with a loop, the else block executes only when the loop completes normally, meaning it wasn't terminated by a break statement. In the provided code, we have a for loop that counts from 0 to 4. Inside the loop, each number is printed out. There is a check to see if the current number is 3, and if so, the loop is broken out of with the break statement. The else clause is associated with this for loop, but it will not execute in this case because the loop was terminated prematurely with a break. If you were to remove the if statement, then the else block would execute after the loop completes. Nested conditional statements. In Python, nested conditional statements refer to the use of one if or if-else clause inside another. This is useful when you need to perform a secondary check after a first condition is met. Just as with regular conditionals, indentation is used to define the scope of the nested conditions. The code first checks if the variable num is greater than 10. If this condition is satisfied, it proceeds to the next level of the conditional, which checks if num is even, i.e., num%2 equals 0. If num passes this second check, and is even is printed. If num is not even, but is odd is printed. If the initial condition is not met, i.e., num is not greater than 10, the else branch prints less than or equal to 10. This demonstrates how nested conditionals are used to make more granular decisions. The while loop. In Python, a while loop is used to repeatedly execute a block of code as long as a given condition is true. It's a way to repeat actions with conditional execution. In the provided code, we initialize a counter variable with the value 0. The while loop starts, and the condition counter 5 is checked. If it's true, the code block inside the loop executes, printing the current value of counter and then incrementing it by 1 with counter plus equals 1. After incrementing, it loops back to check the condition again. This repeats until the condition counter 5 becomes false, at which point the loop terminates and the program moves on to any subsequent code. The for loop. In Python, the for loop is used to iterate over a sequence, such as a list, tuple, dictionary, set or string, or other iterable objects. Iterating over a sequence is called traversal. The for loop allows you to execute a block of code for each item in the sequence. In this example, the range5 function generates a sequence of numbers from 0 to 4. The for loop then iterates over this sequence. In each iteration, the variable number is assigned the next value from the sequence, and the print statement is executed, thus printing each number 0, 1, 2, 3, and 4 on a new line. Loop control statements break, continue, pass. When working with loops in Python, sometimes we need additional control over the loop's execution beyond just its condition. Python provides loop control statements like break, continue, and pass to modify the behavior of loops in various ways. In the code, we have a for loop iterating from 1 to 9. The break statement is used to exit the loop when I is equal to 5, thus the loop stops executing further. If I is an even number, checked by I%2 = 0, the continue statement skips the current iteration and the subsequent print statement, so only the odd numbers are printed up to 4. When an iteration neither breaks nor continues, it encounters the pass statement, which is simply a placeholder that does nothing. The print statement below prints each number unless continue or break is executed. Iterable and iterator. In Python, an iterable is anything you can loop over with a for loop. An iterator is an object that represents a stream of data. You can call next on an iterator to get the next item in the stream. The code initiates a list named myList with 3 elements. By calling iter on this list, we convert the iterable into an iterator stored in iterator. Using next, we obtain the first and second elements from the iterator. Generators and yield. Generators in Python are a simple way to create iterators. They use the yield keyword to generate a sequence of values over time, which allows for efficient execution, as only one item is processed at a time. Unlike lists, the entire sequence does not need to be stored in memory, which is especially useful for large datasets. The provided code defines a generator function Fibonacci sequence that yields the Fibonacci sequence up to n numbers. When the function is called, it doesn't return a single value, but instead returns an iterator object. With each iteration, the next value in the Fibonacci sequence is computed and yielded back to the calling context. The loop for value in Fibonacci 6C10 iterates through the generated Fibonacci numbers and prints them one by one. Once a value is yielded, the function's state is paused, and upon the next iteration, it continues from where it left off. Comprehensions list, dict set. List comprehensions offer a succinct way to create lists based on existing lists or iterables. They transform one list into a new list by applying an expression to each item. This line of code generates a list of squared numbers. The expression xtuff2 is applied to each item in range 10, which generates numbers from 0 to 9, resulting in a new list of those numbers squared. Defining and calling functions. In Python, a function is a block of organized, reusable code that is used to perform a single related action. Functions provide better modularity for your application and a high degree of code reusing. As you already know, Python gives you many built-in functions like print, etc., but you can also create your own functions. These functions are called user-defined functions. In the given code, we define a function named greet that takes one parameter name. The function, when called, prints a greeting message including the name provided. The def keyword is used to define the function, followed by the function name and parentheses containing the parameters. The body of the function is indented and includes the actions the function carries out. We call the function by writing its name, followed by parentheses containing the arguments Alice. This invocation prints "Hello Alice" to the console. Function arguments and parameters. In Python, functions can define parameters that act as placeholders for values, which the user of the function can provide as arguments when calling the function. Understanding the distinction between arguments and parameters and how they interact is crucial for writing clear and versatile functions. In the code, greet is a function that takes 2 parameters, name and message. When we call greet with the arguments Alice and good morning, it prints out "Hello Alice, good morning." Parameters are the variables listed inside the parentheses in the function definition, while arguments are the values passed to the function when it is called. Positional and keyword arguments. In Python functions, arguments can be passed to parameters in 2 ways: as positional arguments, where the order matters, and as keyword arguments, where the name of the parameter is specified during function call, allowing arguments to be passed out of order. In the first function call, Alice is a positional argument matching name. In the second call, Alice is positional, but greeting is specified as a keyword argument with good day as its value. In the third call, both greeting and name are keyword arguments, demonstrating that their order is not important. What matters is the explicit pairing of the argument and the parameter. Default arguments. In Python, functions can have default arguments, which are specified in the function definition. This means that you can assign a default value to a parameter that will be used if the function is called without an argument for that parameter. In the provided code snippet, the function greet is defined with two parameters, name and message. The message parameter has a default value of hello. When the function is called with only the name argument, e.g. greet Alice, it uses the default message value. However, the default can be overridden by providing both arguments, as in greet Bob, good morning, which results in using the provided argument instead of the default. Variable length arguments args and quargs. In Python, functions can be defined to accept a variable number of arguments. The sorargs allows a function to take any number of positional arguments, while swargs lets it accept any number of keyword arguments. This can be useful when the number of arguments is not known beforehand. In the code, func is a function that accepts a variable number of positional and keyword arguments. Sorargs is a tuple that contains all the positional arguments passed to the function. Starquargs is a dictionary that contains all the keyword arguments. When calling func with 3 positional arguments, 1, 2, 3, and 2 keyword arguments, a equals Python, b equals variable length, the function prints out 2 lines showing the representations of args and quargs, demonstrating how the parameters were captured inside the function. Anonymous functions lambda. In Python, anonymous functions are functions that are defined without a name. While normal functions are defined using the def keyword, anonymous functions are defined using the lambda keyword. They are also called lambda functions. Lambda functions can take any number of arguments, but they can only have one expression. The expression is evaluated and returned. Lambda functions are used when a nameless function is required for a short duration. The code defines a lambda function that takes 2 arguments, x and y, and returns their sum. It then assigns this function to the variable add. The print statement calls the add function with the arguments 5 and 7, which prints the result of the lambda function, i.e. 12. Lambda functions are often used to create small, one-time, and inline functions that are not necessary to bind to a name for reuse. Function documentation strings. Function documentation strings, or docstrings, are a way of associating documentation with functions, methods, classes, and modules. They are enclosed in triple quotes and should explain what the function does, its parameters, return values, and any other pertinent information. This documentation can later be accessed via the help function or .doc attribute. In the code, the function addNumbers takes 2 parameters, a and b, and returns their sum. The triple-quoted string immediately following the function definition is the docstring. It details the purpose of the function, parameters with their expected types, and what the function returns. The last part of the code demonstrates how to access the docstring by referencing addNumbers.doc, which would print out the contents of the docstring. Function annotations. Function annotations are a Python feature that allows you to add arbitrary metadata to function parameters and return values. Introduced in Python 3, annotations do not have any inherent meaning or functionality by themselves, but can be used by third-party libraries, IDEs, or linters for type checking, documentation, or other purposes. In the provided function greet, name is annotated with ster to specify that it should be a string, and repeat with int equals 1 to specify that it should be an integer with a default value of 1. The nash str after the parameter list indicates that the function is expected to return a string. These annotations do not affect how the function operates, but serve as hints to users of the function or tools that can check for type correctness. Namespaces and scope. In Python, a namespace is a container that holds a set of identifiers, names, and their associated objects. Each identifier is mapped to an object, and this mapping allows us to access the object using the identifier as a key. Namespaces are created at different moments and have different lifetimes. Scope is a textual region in a Python program, where a namespace is directly accessible. The scope of a name determines the area of a program in which that name is recognized. In the code, global variable is in the global namespace, which means it can be accessed from anywhere inside the program. The outer function defines a local namespace containing outer variable. Inside outer function, there is another function called inner function, which further defines its local namespace with inner variable. When inner function is called, it can access variables in its local scope, the enclosing scope, outer variable, and the global scope, global variable. But notice that inner function cannot access outer variable until inner function itself is inside outer function, lexical scoping. The global and non-local statement. In Python, the global keyword allows you to modify a variable outside of the current scope. It is used to create global variables from a non-global scope, e.g., inside a function. The non-local keyword is used to work with variables inside nested functions, where the variable should not belong to the inner function, but a non-global scope in an outer function. In the provided code, outer function defines a variable a and contains inner function, which uses non-local to refer to the a defined in the outer scope. When inner function is called, it modifies the a defined in outer function, not the global a. The global a remains unchanged until change global function is called, which uses the global keyword to modify the global a. The output shows how the value of a changes in different scopes, demonstrating the use of global and non-local to manage scope in Python. Function returning values. In Python, a function can send back a value to the caller using the return statement. The value returned can be any object, and the function can perform operations and processing before returning. In the given function's sum numbers, it takes two parameters a and b, computes their sum, and assigns it to the variable global total and non-local. The return total statement then sends this function returning values. When sum numbers 5-3 is called, the function returns 8, which is then stored in result and printed. Recursion. Recursion is a concept where a function calls itself directly or indirectly to solve a problem. Each call to itself is typically with a smaller, simpler version of the original problem, leading towards a base case that stops further recursion. In this code, factorial is a recursive function. It calculates the factorial of a number n. If n is 0, it returns 1, base case. Otherwise, it returns n multiplied by the factorial of n minus 1. Every call reduces n by 1, getting closer to the base case. The function continues to call itself with decremented values until it reaches 0, completing the recursion. First-class functions. In Python, functions are first-class citizens, meaning they can be treated like any other object. You can assign them to variables, pass them as arguments to other functions, and even return them as values from other functions. The code defines two functions, square and cube, that calculate the square and cube of a number respectively. The select operation function takes an integer and returns the corresponding function based on the input. This showcases how functions can be returned as values and assigned to variables. The last two lines demonstrate assigning the square function to the variable operation and then calling operation with 5, effectively computing square 5. Higher-order functions. Higher-order functions are functions that can take other functions as arguments, or return a function as a result. This feature allows for a great degree of abstraction and flexibility in your code, making it more concise, readable, and functional in style. In the code snippet, apply_to_1 is a higher-order function because it takes a function f as an argument and applies it to the number 1. The function add3 takes a number x and adds 3 to it. When we call apply_to_1 add3, we pass in add3 as the argument. The apply_to_1 function executes add3 internally, which results in the output 4. This exemplifies the use of higher-order functions to create more dynamic and reusable pieces of logic. Decorators. Decorators are a significant part of Python that allow you to modify the behavior of a function or class. They are a very powerful and useful tool to have in your toolkit, allowing for clean and concise modifications or extensions to the functionality of your existing code. A decorator is essentially a function that takes another function and extends the behavior of the latter function without explicitly modifying it. This code snippet defines a decorator named myDecorator. The decorator itself is a function that takes another function func as its argument. Introduction to modules. A module in Python is a file containing Python definitions and statements. The file name is the module name with the suffix py appended. Modules can define functions, classes, and variables that can be reused in other Python scripts. In this code snippet, we import the math module, which is a standard Python module providing mathematical functions. Then, we call the squart function from the math module to calculate the square root of 16 and print the result. Creating and using modules. In Python, a module is a file containing Python definitions and statements. A module can define functions, classes, and variables that you can use in other Python files. To create a module, simply save your code in a file with a py extension. In the given code, mymodule.py is a simple Python module that defines one function called greeting, which prints a greeting message. The function takes a single argument name. In main.py, we use the import myModule statement to bring our module into scope, allowing us to use the greeting function defined in mymodule.py. By calling mymodule.greeting Alice, we use the greeting function from the mymodule and pass the string Alice as an argument. The import statement. In Python, modules are separate files with Python code that can define functions, classes, or variables. The import statement allows you to use code from these modules in other Python files. In the code provided, the import math statement imports the math module, which contains various mathematical functions. After importing the module, we can access its functions by using dot notation, prefixing the function name with math. The floor function rounds a number down to the nearest integer. Therefore, math.floor 4.75 returns 4, and this value is stored in the variable downRounded. Module search path. When a module is imported into a Python script, the interpreter needs to know where to look for that module. Python follows a specific search path to find the module. Understanding this search path helps in debugging import errors and managing the module hierarchy effectively. The code above prints the list of directories that Python searches for modules in. It uses the sys module, which is always available in Python, and provides access to some variables used or maintained by the interpreter. The sys.path variable is a list of strings that specifies the search path for modules. Initially, this list contains the current directory, Python path, and the installation-dependent default, which typically includes paths to the standard library and site packages directory for third-party packages. Package installation and management pip. Pip is the package installer for Python. It allows you to install and manage additional libraries and dependencies that are not distributed as part of the standard library. Using pip, you can search, download, and install packages from the Python package index, PyPI, and other indexes. This command is used in the terminal or command prompt. Pip install is the command to tell pip to begin installation, and package name should be replaced with the actual name of the package you want to install. This will download the package and any of its dependencies and install them on your system. Virtual environments. In Python, a virtual environment is a self-contained directory that contains a Python installation for a particular version of Python, plus a number of additional packages. Using a virtual environment allows you to manage dependencies for different projects separately, avoiding conflicts between project requirements. Let's look at how to create and use a virtual environment using the venv module, which is included in the Python standard library. The first command, python3 hem venv myenv, creates a new virtual environment inside a directory named myenv. The venv module is called with python3-m, which signifies that the module should be run as a script. Once the virtual environment is created, the second command, source myvenv activate, is used to activate the virtual environment on Unix-like systems. This changes the shell's prompt and indicates that myenv is active, and any packages installed will now be isolated to this environment. The third command, pip install requests, installs the requests package inside the active virtual environment, ensuring it does not affect the global Python installation. Standard modules, OS sysmath, etc. The OS module in Python provides a way of using operating system-dependent functionality, such as reading or writing to the file system, managing paths, and executing shell commands. The code sample above demonstrates the use of two common functions in the OS module, os.getCWD to get the current working directory, and os.listDir path to list entries in that directory. The code imports the OS module, retrieves the current working directory, lists all the files and directories at that path, and prints them out. The dir and help functions. In Python, the dir and help functions are built-in utilities that allow users to interact with the interpreter to learn about objects such as modules, functions, classes, etc. The dir function lists all the attributes and methods of an object. The help function provides a helpful description of an object, which includes things like what module it is from, what its purpose is, and detailed information about its function signatures. In the provided code, we first import the math module, which contains mathematical functions. The dir math call prints a list of all the attributes, including functions, variables, etc., that belong to the math module. This is useful to see everything that you have access to within the module. After that, we use the help math.pow call to print the documentation for the pow function, which is a part of the math module. This documentation includes a description of the function, its parameters, and what it returns, which is valuable for understanding how to use pow. Packages and init.py. In Python, a package is a namespace which can contain multiple packages and modules. It is represented by a directory that must contain a file named init.py. The raw init.py file can be empty, but its presence makes Python treat the directory as a package, allowing you to organize your code into a hierarchical structure. In the above structure, my package is the top-level package directory containing an init.py file. Inside my package, there is module a.py, which is a module of my package. There is also a subpackage, which is a subpackage containing its own init.py file, making it a package as well. Inside subpackage, there is another module, module b.py. Here, the init.py files are used to initialize the packages, potentially executing package initialization code, or defining an all list that specifies which modules the package exports as the API. Namespace packages. Namespace packages allow you to spread subpackages and modules across multiple directories or even distributed repositories. They're different from regular packages because they're not tied to a particular file system location. A namespace package is created when Python encounters a directory with subpackages that doesn't contain a init.py file. The code above helps Python recognize a namespace package. By using pkutil.extendPath, you're adjusting score path, an internal attribute that Python uses to keep track of the paths it should search to find submodules and subpackages within a package. This must be included in the core init.py file at the top-level directory of your namespace package, so Python knows to treat it differently from a regular package. This is less commonly needed in Python 3.3 and above due to changes in how namespace packages are handled. Executable packages. In Python, packages can be made executable by adding a main.py file. When the package directory is run as a script, the score main.py file gets executed. The command python dem mypackage tells Python to execute the main.py file located inside the mypackage directory. This is how Python knows to treat the directory as executable. The score main.py file acts as the entry point for the package, similar to how the main function works in many other programming languages. Opening and closing files. In Python, files are objects you can read from or write to. Opening a file is the process of establishing a connection between your code and the file. Closing a file means terminating the connection properly to ensure all resources are freed up and changes are saved. In this code snippet, we use the open function to open example.txt in read mode, denoted by R. The returned file object is stored in the variable file. We then read the entire content of the file into the variable file content using the read method and print it. Finally, we close the file using the close method to ensure that the resources are properly released. Reading from and writing to files. Reading from a file in Python is a common operation. We typically open a file using the open function, which returns a file object. Then we can use methods like read, readline, or readlines to read the content. In this code snippet, open is used to open example.txt in read mode, R. The with statement ensures that the file is properly closed after its sweep finishes, even if an error occurs. The read method reads the entire content of the file and stores it in the variable content. Finally, the content is printed. File modes. In Python, when you open a file using the open function, you can specify the mode for the file operation. File mode tells the interpreter and developer which actions can be performed on the file, such as reading, writing, or appending. In the provided code, open is used with the mode W, which stands for write. This mode opens the file for writing, creating the file if it does not exist, or overwriting it if it does. The write method is then used to add text to the file. And finally, close is called to ensure that the file is closed properly and all buffers are flushed. The with statement. In Python, the with statement is used for resource management and cleaner code when working with unmanaged resources like file streams. It ensures that resources are properly acquired and released, often used with files to ensure they are closed correctly, even if an error occurs during their use. In the provided code, with opens example.txt in read mode as the object file. The open function returns a file object that's bound to the variable file. Inside the with block, file.read reads the content, which is then printed out. Once the with block is exited, file is automatically closed, even if reading the file raised an exception. Thus, there's no need for explicit file.close calls, preventing file descriptor leaks. File iteration. File iteration in Python allows you to go through each line of a file using a loop. This is efficient for reading large files, as it does not load the entire file into memory at once. In the provided code, example.txt is opened in read R mode, which means the file is opened for reading and no changes can be made to it directly. The with statement is used to ensure the file is properly closed after its sweep finishes. Inside the with block, a for loop is used to iterate through each line in the file. The line variable contains the text of the current line. Print line end equals is used to print each line without adding extra new lines, as each line already ends with a new line character by default. After the block, the file is automatically closed. Handling file exceptions. When dealing with files, you may encounter various issues, like the file not existing, not having permission to access the file, or running into problems while reading or writing data. Python uses exceptions to handle errors and exceptions that may come up during file operations. The most common way to handle these exceptions is by using a try-except block. In the code, we attempt to open a file, example.txt, in read mode. If the file does not exist, a file not found error will be raised, and we catch that specific exception to print a user-friendly message. If any other exception is thrown during file handling, it will be caught by the generic accept exception as EP block. This is a more generic exception handler that captures any exception that was not explicitly caught by the previous except clauses and prints an error message, including the exception that occurred. This approach ensures our program can handle unexpected issues gracefully without crashing. Working with paths. In Python, paths can be manipulated using the os.path module, which provides functions for interacting with file system paths in a platform-neutral way. Working with paths is crucial for file operations such as reading and writing. This code demonstrates how to work with file paths using the os.path module. os.getCwd retrieves the current working directory, and os.pathJoin is used to construct a path by concatenating directory names. os.path.split separates the path into a head, directory path, and tail file name. os.path.exists checks if the path exists in the file system. Lastly, os.path.splitExt splits the file name from its extension, providing the file name without it. Directory and file operations OS module. The OS module in Python provides a way of using operating system dependent functionality. It allows you to interface with the underlying operating system that Python is running on, be that Windows, Mac, or Linux. You can perform several operations with it, such as creating a directory, renaming files, deleting paths, etc. First, we imported the OS module which is necessary to perform the directory and file operations. We then used os.getCD to print the current working directory. The os.listDar provides a list of all files and directories in the current directory. To create a new directory, we used os.mkdir, new directory. Then we renamed this directory with os.rename, new directory, renamed directory. Finally, we removed the directory with os.rmdir, renamed directory. Remember to handle exceptions in real code to manage directories that may not exist or have permission issues. File metadata. In computing, file metadata provides information about other data. In Python, the os and os.path modules allow you to access metadata of a file, such as size, modification date, and permissions. This code snippet demonstrates how to retrieve different pieces of metadata for a given file named example.txt. We import the os module to interact with the operating system. os.path.getSize returns the size of the file in bytes. os.path.getMtime returns the time of last modification as a timestamp since the epoch, number of seconds since January 1st, 1970. os.stat returns an object with various attributes, from which stmode represents the file's mode, permissions. Syntax errors versus exceptions. Syntax errors occur when the parser detects an incorrect statement. This could happen if you forget a symbol or mistype a command. Let's look at an example where a colon is missing at the end of an if statement, which is a common syntax error. In the code provided, we're missing a colon after the if true statement, which is necessary in Python to define the start of a block of code. This results in a syntax error, indicating that the code cannot be parsed due to its incorrect structure. Handling exceptions. In Python, exceptions are events that occur during execution that disrupt the normal flow of a program. When an exception occurs, Python stops what it is doing and passes the error up to the closest exception handler for resolution. If no handler is found, the program crashes. To prevent this, we can anticipate and handle exceptions using the try-except block. In this code snippet, we're attempting to divide 10 by 0, which causes a zero division error exception. The try block contains the code that may cause an exception. Following the try block, the except block captures and handles the specific exception type, zero division error. When the division by 0 is attempted, Python throws a zero division error, which is then caught in the except block, and a message is printed to the user. If the exception was of a different type not handled by the specified except block, the program would still crash. The try except finally clause. The try except finally construct in Python is used to handle errors gracefully. It allows a program to continue execution even when an exception occurs. The try block contains the code that might raise an exception. The except block catches the exception and allows you to respond or recover. The finally block is optional and executes regardless of whether an exception occurred or not, often used for cleaning up resources. In this code snippet, the try block attempts to divide x by y. If y is 0, a zero division error is raised, and the code in the except block is executed, notifying the user of the error. After the try and except blocks are executed, regardless of whether an exception was raised or not, the finally block will execute, displaying a completion message. It's a good practice to use the finally block to release external resources, such as files or network connections, ensuring that they are properly released no matter what happens in the try block. Built-in exceptions. Python comes with a variety of built-in exceptions that handle different types of errors which arise during the program execution. When errors occur, Python generates an exception that can be handled, which avoids your program from crashing. The common built-in exceptions in Python include index error, when accessing an index not in a sequence, key error, for missing keys in a dictionary, type error, when an operation is applied to an object of inappropriate type, value error, when a function receives an argument with the correct type but inappropriate value, file not found error, when a file or directory is requested but doesn't exist, and zero division error, when dividing by 0. Each type of exception helps the programmer understand what kind of error has occurred. Raising exceptions. In Python, exceptions can be raised to interrupt program flow when an error occurs. This can be done using the raise statement, which allows you to throw an exception if a certain condition is met, or if you wish to create a custom error scenario. In the provided code, we define a function checkAge that takes an argument age. If age is less than 0, it raises a value error with a message indicating the age cannot be negative. Similarly, if age is greater than 120, a value error is raised indicating that the age is not valid. If the age is within valid bounds, a message stating age is valid is printed. In the try block, we call check age with an invalid age, -5. When the invalid age is passed, the value error is raised, and the message associated with the value error is caught and printed in the except block. Creating custom exceptions. Custom exceptions provide a way to define and handle specific error scenarios that aren't covered by Python's built-in exceptions. By creating custom exceptions, you can add clear, descriptive error handling that is specific to your application's context. In the provided code, custom error is a new class derived from the base class exception. This is a common practice for creating custom exceptions. The constructor init takes an optional message parameter, which defaults to a generic message when not provided. By calling super_init self.message, it ensures that the base class initialization happens correctly. In the try block, custom error is raised with a custom message. In the except block, the custom exception is caught and its message is printed, demonstrating how it could be handled during execution. Assertions. Assertions in Python are a debugging aid that tests a condition as an internal self-check in your program. They are used to assert that a certain condition is essential for your code to function correctly. If the condition is true, the program continues. If false, an assertion error is raised, optionally with a provided message. In the provided code, assert is used to ensure that the variable x is a non-negative number. If x happens to be negative, the program will raise an assertion error with the message, only positive numbers are allowed here. Assertions are mainly used during development and debugging and should not replace proper error handling in production code. Classes and objects. In object-oriented programming, a class is a blueprint for creating objects. Classes encapsulate data for the object and methods to manipulate that data. An object is an instance of a class with its own set of values for the attributes defined by the class. In the provided code, we declare a class named dog with an init method, which is the initializer for the class, setting attributes like name and age. We also define a method bark, which returns a string of the dog barking. When we create an instance myDog, we are creating an object of the class dog. We then call the bark method on myDog, which prints Buddy says woof. Attributes and methods. In the context of Python's object-oriented programming, attributes are variables that hold data about the state of an object, while methods are functions that define the behavior of an object. Attributes are like properties of an object, and methods can be seen as actions an object can perform. The car class has two attributes, color and mileage, initialized through the init method. It also has a method drive that takes the distance parameter and adds it to the mileage attribute, effectively simulating the act of driving the car. An instance of the car class is created with red color and 0 mileage. The drive method is called with 100 distance, which updates the mileage of my car to 100. The print statements display the attributes color and mileage of the myCar object before and after calling the drive method. Constructor init method. In Python, a constructor is a special method that is automatically called when an object of a class is created. The init method is used for initializing the instance variables of a class, setting up the initial state of objects, and performing any setup necessary when an object is created. In the provided code, the car class has an init method that takes 4 parameters: self, make, model, and year. The self parameter represents the instance of the class and is automatically passed by Python. The other parameters are used to initialize the instance variables. When a car object is created with car1 equals car Honda Civic 2020, the scoreInit method is invoked, and Honda, Civic, and 2020 are passed as arguments to set the make, model, and year instance variables respectively. Instance class and static methods. In Python, methods within a class definition can be defined as instance methods, class methods, or static methods. Instance methods are the default and take self as their first parameter. Class methods take CLS as their first parameter and are decorated with @class method. Static methods don't take self or CLS and are decorated with @static method. Each type serves a different purpose within the class. The instance method requires an instance of my class to be called and can access the instance through self and its attributes. The class method can be called on the class itself without creating an instance and can access class attributes through CLS. The static method does not have access to the instance self or the class CLS and is basically just a function inside a class that doesn't operate on the class or instance. Inheritance. Inheritance allows us to define a class that inherits all the methods and properties from another class. The class being inherited from is called the parent or superclass, while the class that inherits is called the child or subclass. In the provided code, animal is a parent class with a constructor to set the name and a method speak. Dog and cat are subclasses that inherit from animal and override the speak method to provide specific animal sounds. When instances of dog and cat are created and their speak method is called, they return their unique sound phrases. Multiple inheritance. Multiple inheritance is a feature in some object-oriented programming languages in which a class can inherit behaviors and attributes from more than one parent class. This allows for the creation of a new class that combines the functionality of the inherited classes. The code defines two parent classes, parent1 and parent2, each with their own method, func1 and func2 respectively. The child class is then defined, inheriting from both parent1 and parent2, allowing it to access methods from both parents. The child instance of child demonstrates how the methods can then be called, showing multiple inheritance in action. When invoking methods, Python's method resolution order, MRO, determines the order in which parent methods are traversed. Polymorphism. Polymorphism in Python allows different objects to be treated as if they are objects of the same class through a common interface. It uses a shared method signature, with each object implementing the method in its own way. This concept is useful for creating flexible and extendable code. The code defines two classes, dog and cat, each with a method sound that returns the respective animal sound. The function animal sound takes an animal object and calls its sound method. This demonstrates polymorphism, where an object can be passed to a function expecting an animal object with a sound method. It doesn't matter which subclass of animal is passed. As long as it implements the sound method, the function can use it, hence the method sound is polymorphic. The animal sound function is used to print the sounds of different animal types, showing that they can be treated uniformly without knowing their exact class type. Encapsulation. Encapsulation is a fundamental concept in object-oriented programming, OOP. It describes the bundling of data and the methods that operate on that data within one unit, e.g. a class. This concept also restricts direct access to some of an object's components, which is a means of preventing accidental interference and misuse of the data. The main way to achieve encapsulation is through the use of access modifiers like private and public. The bank account class encapsulates the account number and the balance by making them private, with 2 underscores. This ensures that these variables cannot be directly accessed or modified from outside the class, enforcing a layer of security and data integrity. Methods like deposit and withdraw are provided to interact with these variables in a controlled way. The getBalance and setCoreBalance methods are known as getter and setter methods, allowing retrieval and updating of balance while maintaining validation rules. Access modifiers, public, protected, private. In Python, access modifiers determine the accessibility of class members. By default, all members of a class are public. However, we use a convention to define protected and private members using underscores for protected and for private. The example defines a class with different types of access modifiers. Public var can be accessed from anywhere. Protected var is meant to be used within the class and subclasses and conventionally indicated by a single underscore. And score private var is the most restricted, accessible only within the class and indicated by double underscores. Private methods follow the same naming convention. Remember that Python does not enforce access restrictions as strongly as other languages like Java or C++. They are guidelines rather than hard rules. Special methods, magic dunder methods. In Python, special methods, also known as magic or dunder methods, are methods that are prefixed and suffixed with double underscores. They are used to define how an object should react to certain operations that are intrinsic to Python, such as arithmetic operations, attribute access, iteration, representation, and more. These methods enable us to emulate the behavior of built-in types or to implement behavior specific to our user-defined classes. In this code snippet, we define a class circle with a few special methods. Init sets the initial state of the object. Score* defines the informal string representation of an object that is readable and useful for end users. REPL provides the official, unambiguous string representation of an object, which ideally can be fed back to eval to recreate the object. Furthermore, add allows us to define what happens when we use the plus operator with our objects, by adding the radii in this case, and lt allows us to use the less than operator to compare two circle instances based on their radii. The use of isInstance ensures type safety during these operations. Property. In Python, a property is used to control access to instance variables. It acts as an interface for instance data, allowing for additional logic to be executed when an attribute is accessed or modified, such as type checking or validation. This is typically achieved using the @property decorator to define getter, setter, and deleter methods. The given code defines a circle class with a private instance variable scoreRadius. The @property decorator is used to define a getter method radius that allows the user to access the radius value. The @radius.setter decorator defines a setter method that controls how the radius value can be set. The setter includes a validation check to ensure the radius is non-negative. Otherwise, it raises a value error. This approach encapsulates the radius attribute, protecting it from being set to invalid values directly. Class and static variables. In Python, class variables are shared across all instances of a class. They can be accessed directly by the class itself or by its instances. Static variables, a concept borrowed from other languages, are essentially the same as class variables in Python and are used to define properties or behaviors that are not tied to any particular instance of the class. In the code example, class variable is a class variable that belongs to the class myClass itself, not to any instance of the class. No matter how many instances of myClass you create, there is only one copy of class variable. The static method is a static method decorated with @static method, which has access to the class variable, but not to instance-level data. As such, static methods can be called on the class itself without needing an instance. They behave like regular functions, but belong to the class's namespace. Datetime module. The datetime module in Python provides classes for manipulating dates and times. With this module, you can create objects that represent dates, times, and combined datetime objects, as well as durations and time zones. The module is particularly useful for creating timestamps, performing date arithmetic, formatting dates, or parsing date strings. This piece of code imports the datetime class from the datetime module. It then retrieves the current date and time using datetime.now and stores it in the variable current time. After that, it prints the full current date time and extracts specific components, year, month, day, hour, minute, second, from the current time object, printing each one separately. This demonstrates how to access various date and time components from a datetime object. Collections module. The collections module in Python provides specialized container data types that extend the capabilities of the default dict, list, set, and tuple types. These include named tuple, which allows you to create tuple subclasses with named fields, dequeue for high performance, double-ended queues, counter for counting hashable objects, ordered dict for dictionaries that maintain their order, and default dict, which provides a default value for missing keys. In this code snippet, we use 5 classes from the collections module. First, we define a point name tuple, which is a tuples or subclass with named fields for more readable code. Next, we create a deque with initial elements and use append left and pop to modify it. Then, we instantiate a counter to count the frequency of each character in a string. After that, an ordered dict is created with a defined item order regardless of how keys were added. Lastly, we show how a default dict can be used to automatically initialize a missing key with an integer type default value. IterTools module. The IterTools module in Python provides various functions that return iterators for efficient looping. It offers combinatory functions like product, permutations, and combinations, as well as infinite iterators and those that work on iterables, like chain, islice, or group by. The code demonstrates 3 IterTools functions. Count creates an iterator that starts at 0 and counts up indefinitely. We use a break statement to exit the loop after reaching the number 5. Cycle cycles through the provided list indefinitely. In this case, we stop after 1 full cycle for demonstration. Repeat returns an object over and over, which we limit to 3 times using the times argument. Each of these functions are examples of infinite iterators provided by the IterTools module. FuncTools module. The FuncTools module provides higher-order functions and operations on callable objects. One such utility is partial, which allows us to freeze some portion of a function's arguments and keywords, resulting in a new object. In the provided code, partial is used to create a new function double that always multiplies its input by 2. When double 5 is called, it uses multiply with 2 as the first argument and 5 as the second, resulting in the output 10. Math module. The math module provides access to various mathematical functions. These include trigonometric functions, representation functions, logarithmic functions, etc. Here we'll look into some basic functions like floor, ceil, and squaret. In this code, we import the math module and define a floating point number 9.6. We use math.floorNumber to get the largest integer less than or equal to 9.6, which is 9. The math.ceilNumber function returns the smallest integer greater than 9.6, which is 10. Finally, math.number calculates the square root of 9.6. Random module. The random module in Python is used to generate pseudo-random numbers for various distributions, including integers, floating point, sequences, etc. It's a part of the Python standard library, which means it doesn't require any extra installation. The code first imports the random module. It uses randint to generate a random integer between 0 and 10, inclusive. Then it generates a random float between 0 and 1, using the random function. Lastly, it selects a random element from a given list using choice. Each of these functions utilizes pseudo-random number generators that are sufficient for non-cryptographic purposes. Statistics module. The statistics module in Python provides functions for calculating mathematical statistics of numeric data. It offers measures of central location like mean, median, and mode, and measures of spread like variance and standard deviation. The provided code imports the statistics module and defines a list named data with numerical values. The mean function calculates the average of the data. Median finds the middle value when the data is sorted, and mode identifies the most common data point. The variance function measures the spread of the data around the mean, and stdev computes the standard deviation, which is the square root of the variance. Each of these functions is applied to the data list, and the results are stored in their respective variables. REPL for regular expressions. In Python, the REPL module provides a set of functions and classes for working with regular expressions. Regular expressions are a powerful tool for processing text. They enable you to match patterns in strings and extract or manipulate text according to those patterns. In this code snippet, we import the REPL module and define a regular expression pattern to match any sequence of alphabetical characters that are bounded by word boundaries. The pattern R, BAZZ plus B, matches entire words, denoted by B, the word boundary. The function re.findAll scans the string text and returns a list of all matches of the pattern within the text. The result is then printed, showing a list of all words found in the text string. Logging module. The logging module in Python is used for tracking events that happen when software runs. It can be set to output messages to different destinations, like the console or a file. Logging is better than printing because you can set the level of importance for the messages and decide what to output or ignore. In this code sample, we import the logging module and set the basic configuration with a logging level of info. We create a logger object for the current module. We then log messages at different severity levels: info, warning, and error. Only messages that are equal or higher than info level will be printed to the console. JSON module. The JSON module in Python provides an easy way to encode and decode data in JSON, JavaScript object notation. It's commonly used for transmitting data in web applications. The module can take Python objects, typically dictionaries and lists, and convert them to JSON strings. It can also take JSON strings and convert them back to Python objects. In the provided code, we first import the JSON module. Then we create a Python dictionary called data. We use the json.dumps function to convert the data dictionary to a JSON formatted string, which is stored in the JSON string variable. To reverse the process, we use json.loads, which takes a JSON string and converts it back to a Python dictionary, as seen in decoded data. This process is commonly known as serialization, dumps, and deserialization, loads. CSV module. The CSV module in Python is used for reading and writing tabular data in CSV, comma-separated values format. The module defines classes to read and write tabular data in CSV format. It allows programmers to say, write this data in the format preferred by Excel, or read data from this file, which was generated by Excel, without knowing the precise details of the CSV format used by Excel. The code demonstrates how to use the CSV module to write to and read from a CSV file. First, it imports the CSV module. Then it opens a file named example.csv in write mode and creates a csv.writer object associated with it. Using write_row, it writes rows of data to the CSV file. Next, it reopens the same file in read mode and creates a csv.reader object to read the data. It then iterates over the rows in the file and prints them. XML eTree element tree module. The XML.eTree element tree module provides a simple and efficient API for parsing and creating XML data. It's a part of Python's standard library and allows for XML to be treated as a tree structure, where elements are nodes and attributes properties are details of those nodes. This makes it an ideal tool for working with XML documents in Python. The provided code imports the element tree module and parses an XML string with two child elements. The from string function passes the XML from a string and returns the root element. The code then accesses the first child by indexing the root, root0, and prints its tag, child1, and attributes, name, child1. This demonstrates basic parsing and accessing of XML elements with element tree. SQLite 3 module. The SQLite 3 module in Python's standard library allows for interaction with SQLite databases. It provides an SQL interface compliant with the DB API 2.0 specification designed by the Python Database API specification v2.0. SQLite is a C library that provides a lightweight disk-based database, which doesn't require a separate server process and allows access using a non-standard variant of the SQL query language. In the provided code, we first import the SQLite 3 module. A connection to the database example.db is created using SQLite3.connect. A cursor, which is used to traverse and operate on the database, is created from the connection object. The cursor.execute method executes SQL commands. We create a table stocks with 5 columns if it does not already exist, and then insert a new row into that table. Data is committed to the database with con.commit, and the database connection is closed with con.close to release resources and ensure changes are saved. Subprocess module. The subprocess module allows you to spawn new processes, connect to their input-output error pipes, and obtain their return codes. This module intends to replace older modules and functions, such as os.system and os.spawnShaw. It provides more powerful ways to manage and communicate with subprocesses. In the provided code, we import the subprocess module and use it to run the shell command ls-l, which lists files in long format. We capture the standard output and standard error by setting stedout and stder to subprocess.pipe. The text equals true argument indicates that we expect the output as a string rather than bytes. Once the subprocess completes, we print the captured standard output and standard error. Completed process is an instance of subprocess.completedProcess, which contains the output data and other information like return code. Multiprocessing module. The multiprocessing module in Python's standard library allows the programmer to create processes that can run in parallel. This is especially useful for CPU-bound processing and can lead to significant speed improvements for certain types of programs. The module provides both high and low-level ways to manage multiple processes, as is similar in spirit to the threading module, but uses separate memory spaces. This basic example demonstrates how to use the process class from the multiprocessing module. The concept is similar to threading, but each process runs in its own memory space. The process class takes a target function to run and any arguments for that function. The start method begins the process's execution, and join tells the main program to wait for the process to complete. Threads and threading module. In Python, the threading module is used to run multiple threads, tasks, function calls at the same time. This is helpful when you want to perform several operations simultaneously, like reading from a disk, while still keeping the user interface responsive. Socket module. The socket module in Python provides access to the BSD socket interface. It facilitates the creation of network connections and the implementation of communication endpoints. A socket is one of the most fundamental technologies of computer network programming. The code imports the socket module and creates a socket object. It then retrieves the host name of the local machine and specifies a port number to listen for incoming connections. It binds the socket to the given host and port and starts listening with a queue size of 5. Finally, it enters a loop where it accepts incoming connections, prints the address of the connecting client, sends a thank you message back to the client, and closes the connection. Note, running this code snippet as is will create a server that can cause the terminal to wait indefinitely for a connection. It's meant to illustrate the use of sockets in a server context. Email and SMTP-lib module. The email module allows you to manage email messages, including creating, parsing, and manipulating various parts of an email, like the body, headers, and attachments. The SMTP-lib module defines an SMTP client session object that can be used to send mail using Simple Mail Transfer Protocol (SMTP). Python's SMTP-lib only establishes a session and sends email to the SMTP server, meaning it does not include any facilities for composing or receiving messages. This is where the email module comes in, which provides a set of classes for constructing messages. You use email to create a message object with the sender and receiver's email addresses, subject, and body, and then use SMTP-lib to send the message object. Together, email and SMTP-lib provide a complete solution for sending emails through Python scripts. Unit test module. Python's unit test module is a testing framework derived from Junit. It allows you to create test cases by subclassing unitest.testCase. Within these subclasses, you can define methods that start with test to indicate test functions. This module provides a plethora of assert methods to check for various conditions. This code snippet demonstrates a basic test case using the unitest module. It imports unitest and creates a subclass of unitest.testCase called simpletest. Within simpletest, there is a method, testAddition, that checks if the addition of 1 and 1 equals 2 using the assertEqual method. Finally, it calls unitest.main to run the tests when the script is executed directly. Iterators and generators. In Python, an iterator is an object which implements the iterator protocol, consisting of the methods or_iter and next. The squares iterator class generates squares of numbers up to a specified limit. It is an iterator because it has iter that returns the object itself and a next that returns the next value or raises stop iteration. Context managers. Context managers in Python are used to properly manage resources like file streams or database connections, ensuring these resources are properly cleaned up after use, even in the event of an error. They are commonly used with the with statement, which provides a way to set up a context for a block of code and properly close it. Let's explore how to use a context manager with a file operation. In the provided code, the context manager is created using the open function, which opens the file example.txt in write mode, W. The with statement then establishes a context in which the file operations take place. The file handle file is only valid within the block of the with statement. When the block is exited, either after the normal execution of the block or if an exception occurs, the open context manager ensures the file is properly closed. This prevents file descriptor leaks and ensures that the written data is properly saved to the disk. Coroutines and async I/O. Coroutines are an advanced Python feature that allows you to write asynchronous code using a synchronous style. This is particularly useful for I/O-bound tasks. Async I/O is a library that provides infrastructure for writing single-threaded concurrent code using coroutines, multiplexing I/O access over sockets and other resources. Here's how to define and run a simple coroutine with the asyncio module. First, we import the asyncio module. We define a coroutine with async def. Inside the coroutine myCoroutine, we use print to output hello. Then, we use await to yield control back to the event loop, letting it sleep for 1 second without blocking. After the sleep, print outputs world. Asyncio.run is used to run the top-level coroutine and cannot be called when another asyncio event loop is running. Descriptors. Descriptors are a low-level mechanism for behavior attribute access in Python. When building reusable pieces of code, you may require more control over how attributes are accessed and set within your classes. A descriptor is a class that implements any of get, set, or delete methods. These methods are used to manage the access to another object attributes. In the code, descriptor is defining get, set, and delete operations for the attribute of myClass. When the attribute of myClass is accessed, descriptor.get is called, printing a message and returning the stored value. When the attribute is set, descriptor.sets is called, printing a message and updating the value. When attribute is deleted, descriptor.delete is invoked, printing a message and deleting the attribute. Descriptors facilitate the building of custom and controlled attribute access in classes. Metaclasses. Metaclasses are the classes of a class, a deep concept in Python that allows you to modify the behavior of a class. A metaclass defines how a class behaves. A class itself is an instance of a metaclass. The code defines a metaclass meta that inherits from type, the default metaclass in Python. Inside it, the new method is overridden to add a print statement whenever a new class is created with this metaclass. The myClass class is then defined with meta as its metaclass. So when myClass is created, you will see creating class myClass printed out. The metaclass allows us to modify the class creation process. Decorators. Decorators are a significant part of Python, allowing you to modify the behavior of functions or methods. They allow a programmer to wrap another function in order to extend the behavior of the wrapped function without permanently modifying it. Memoization and caching. Memoization is an optimization technique used to speed up function execution by storing the results of expensive function calls and returning the cached result when the same inputs occur again. The code demonstrates memoization using a dictionary to cache results of the Fibonacci sequence calculations. When the function is called, it first checks if the result for the given n is already in the memo dictionary. If it is, the cached result is returned, avoiding redundant computations. If not, it calculates the value, stores it in memo, and then returns it. This significantly reduces the number of calculations, especially for large values of n, leading to faster execution times. Python optimization techniques. Optimization in Python involves techniques that improve the efficiency of code, both in terms of execution speed and resource consumption. Here we'll explore some common strategies. This code snippet benchmarks the execution speed of a list comprehension versus a traditional for loop using the timeIt module. List comprehensions are generally faster because they are optimized by Python's internal C loops, whereas the for loop is executed at the bytecode level. Garbage collection. Garbage collection in Python is the process by which Python automatically reclaims memory by deleting objects that are no longer referenced in a program. Python uses a form of automatic memory management known as reference counting, and also employs a cyclic garbage collector to detect and collect circular references. Below is an example that illustrates how Python's garbage collector works and how you can interact with it using the GC module. In this example, we import the GC module, which provides the collect function to force garbage collection to happen immediately. An instance of myClass is created, and then its only reference is deleted using the del statement. This decreases the reference count of the myClass instance to 0, allowing the garbage collector to reclaim its memory. When gc.collect is called, it triggers the garbage collection process, and you should see the message, My class instance deleted, printed to the console, indicating that the GORDEL method of myClass was called. Dynamic typing and duck typing. Dynamic typing means that a variable is simply a name bound to an object, and the type of the object can change over time. Python is a dynamically typed language which allows reassignment of variables to objects of different types. Here's a simple example. In the code, the variable x is first assigned to an integer 5, and the type of x is printed, which is class int. Then x is reassigned to a string hello, and its type is printed again, showing class s*. This flexibility is a feature of dynamic typing. Writing C extension modules. Python is an extensible language, and one way to extend its capabilities is by writing modules in C. C extensions can speed up execution and allow Python to interact with existing C code. To create a C extension, you typically define functions in C, create a module definition, and use the Python C API to integrate with Python. The provided C code snippet demonstrates the basic structure of a C extension for Python. Method hello is a simple example of a C function that returns the classic hello world string as a Python Unicode object. The simple methods array is used to register the module's methods, indicating the function name in Python, the C function, calling convention, and docstring. The simple module structure provides module-level information. Finally, pyinit simple module is the module initialization function that is called when the module is imported in Python, creating and returning the module object. Numpy introduction and arrays. Numpy is a powerful Python library for numerical processing. It provides support for large, multi-dimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. Numpy arrays are faster and more compact than Python lists. A Numpy array is a grid of values, all of the same type, and is indexed by a tuple of non-negative integers. The code block begins by importing the Numpy library with the alias np. Then, it creates a Numpy array named r containing 5 integers. It uses the np.array function to convert a Python list into a Numpy array. Finally, the code prints the array and confirms the type of r using the type function, which should output class numpy.endArray. Numpy arrays come with benefits such as efficiency, convenience, and the use of less memory than Python lists. Numpy array operations. Numpy provides a variety of operations that can be applied on arrays, which are much faster than if you did them in pure Python. Operations include element-wise arithmetic, scalar arithmetic, and universal functions, ufuncs. The following code demonstrates basic arithmetic operations on Numpy arrays. The code first imports the Numpy library and then creates 2 one-dimensional arrays, array1 and array2. It performs element-wise addition, subtraction, multiplication, and division on these arrays. Array sum holds the result of addition, array diff of subtraction, array product of multiplication, and array quotient of division. The results are printed out, demonstrating how operations are applied to each corresponding element pair across the 2 arrays. Pandas series and data frame. Pandas series is a one-dimensional labeled array capable of holding any data type. It is similar to a column in a spreadsheet, and it can have a name for identification. The provided code imports the Pandas library as PD and then creates a Pandas series named mySeries. The series is created using a list of integers 4, 7, 95, 3, and a name numbers is attached to it for reference. When printed, it shows the values along with the automatically generated integer index for each value. Data cleaning and preparation. Data cleaning and preparation involve a variety of processes designed to transform raw data into a format that is suitable for analysis. It typically includes handling missing data, removing duplicates, converting data types, and normalizing data. In this example, we use Pandas to create a data frame with missing values in different columns. The fillna method is used with the method equals fill argument, which stands for forward fill. This method fills the missing values with the last non-null value encountered in the column. If the first value is missing, it remains NaN, because there is no previous value to carry forward. Data wrangling, join, combine, reshape. In data analysis, joining is combining columns from two different data frames based on a common key. This operation resembles join in SQL. The code creates two data frames, df1 and df2, each with its own columns, and a third data frame, df3, with a different set of columns. Then, it joins df1 with df3 using the outer method, which includes all rows from both data frames, filling in nan where data is missing. The index is used as the joining key. Plotting and visualization with Matplotlib. Matplotlib is a versatile plotting library in Python, commonly used for data visualization. It provides an object-oriented API for embedding plots into applications. The code imports Matplotlib's pyplot module. Pyplot is a collection of functions that make Matplotlib work like MATLAB. Each pyplot function makes some change to a figure, e.g. creates a figure, creates a plotting area, plots some lines, decorates the plot with labels, etc. In this simple example, a list of numbers is plotted on the y-axis, while the x-axis gets the default index values. Finally, bulk.show is called to display the plot to the user. Plotting with Seaborn. Seaborn is a powerful Python data visualization library based on Matplotlib that provides a high-level interface for drawing attractive statistical graphics. It works well with Pandas data structures and offers a variety of plot styles and color palettes to make statistical plots more attractive and informative. In the code provided, Seaborn is imported as SNS, and matplotlib.pyplot is imported as PLT, which are common conventions. The tips dataset, which is included with Seaborn, is then loaded into a data frame df. The scatterplot method is used to create a scatterplot with total bill on the x-axis and tip on the y-axis, indicating a possible relationship between the total bill and the tip given. Finally, plt.show is called to display the plot. Introduction to data mining. Data mining is the process of discovering patterns and knowledge from large amounts of data. The data source could be databases, data warehouses, the internet, or other data repositories. The process is similar to mining for gold. You have a large amount of material to sift through to find valuable nuggets. In Python, one of the ways to perform data mining is by using the Pandas library to manipulate data and the scikit-learn library to apply data mining algorithms. In the provided code, we first import the Pandas library to load and manipulate the data, and from scikit-learn, we import the k-means class to perform a clustering algorithm. We then load a dataset from dataset.csv into a Pandas data frame. We apply the k-means algorithm to find 3 clusters within our data, and after fitting the model to the data, we predict the cluster for each instance. Finally, we add a new column to our data frame called cluster, which contains the cluster label that the k-means algorithm assigned to each row in the data. Simple statistical analysis. Simple statistical analysis involves using basic statistical measures to understand the general characteristics of a dataset. Common measures include the mean, average, median, middle value, mode, most frequent value, standard deviation, variability measure, and quantiles, values at specific percentiles. Python's libraries, such as Pandas and Numpy, provide built-in functions to calculate these statistics easily. A data frame object is created from a dictionary with a list of integers. The .describe method returns a series including mean, standard deviation, minimum, maximum, and quantiles. The .median function gets the median, and .mode retrieves the mode. If multiple modes exist, 0 ensures only the first is displayed. Working with time series data. Time series data refers to a sequence of values recorded at specific time intervals. Analyzing such data involves handling dates and times, often requiring resampling, time zone management, and time-based indexing. Python's Pandas library offers extensive functions for time series analysis. In this example, we'll see how to create a Pandas data frame with date-time index and perform a basic time series operation like resampling to get the mean values by end of the month. First, we import the Pandas and Numpy libraries. We create a date-time index called RNG with daily frequency starting from January 1st, 2023 for 100 days. Then, we create a Pandas series TS with random values using NumPy's random.randn function, using RNG as the index. Finally, we resample this time series data to get the mean of the values at the end of each month. M stands for month-end frequency, and print the result. The resample method is a powerful tool for frequency conversion and resampling of time series data. Web scraping with Beautiful Soup. Web scraping is a technique used to extract data from websites through an automated process. Beautiful Soup is a Python library that simplifies this task by parsing HTML and XML documents into a readable tree structure. It allows for easy navigation, searching, and modification of the parse tree. Before starting, you'll need to install the Beautiful Soup 4 package using pip and also requests to fetch the web page. In this code snippet, we import Beautiful Soup from the BS4 package and the requests library. We define the URL h/example.com, which is a placeholder for the actual website we want to scrape, and then make an HTTP GET request to fetch the contents of that page. The content of the response is passed to Beautiful Soup, along with the HTML.parser argument to specify the parser. We then find the title tag, extract its text using the getText method, and print the title of the web page. This is a simple demonstration of web scraping using Beautiful Soup. Introduction to Web Frameworks. A web framework is a code library that makes web development faster and easier by providing common patterns for building reliable, scalable, and maintainable web applications. Python offers several web frameworks, such as Django, Flask, and Pyramid, each with its own strengths. The provided code is a basic example of a web application using the Flask framework, one of the most popular Python web frameworks. The atapp.root decorator tells Flask that the function hello world should be called when the root URL / is accessed. The function returns the string hello world, which is then displayed in the web browser. Running this script starts a local web server that can be accessed at http://localhost 5000 by default. Flask basics and routing. Flask is a lightweight WSGI, web server gateway interface, web application framework in Python. It is designed to make getting started quick and easy, with the ability to scale up to complex applications. Routing in Flask is the process of mapping URLs to specific functions that handle what happens when a specific endpoint is reached. This code creates a basic Flask web application. We first import the Flask class. An instance of this class will be our WSGI application. The app.route decorator is used to tell Flask what URL should trigger the associated function. In this case, the root URL / is mapped to the hello world function that returns hello world. When run, the application starts a local development server that listens for requests at the root URL and responds with hello world. The debug =true argument enables the debugger and reloader for a better development experience. Flask templates and static files. Flask utilizes Jinja 2 as its template engine to render HTML files on the server side before sending them to the client. Static files, such as CSS, JavaScript, and images, are served separately from these templates and do not change per request. Flask allows us to manage these efficiently. In the code above, a Flask application is created. The render template function is used to render index.html, a template located in the templates directory. When visiting the root URL, home function will be called and index.html will be displayed in the web browser. The application is then run with debug =true for development purposes, which allows automatic reloading and provides a debugger. Flask form handling and file upload. In Flask web development, handling forms and file uploads is a common task. Flask leverages HTTP methods to process form data and the Workzeuge library to handle file uploads. To protect against CSRF attacks, Flask WTF, an extension to Flask that integrates with the Doha forms, is used. Let's see a simple example that includes a form with text inputs and file uploads. The code outlines a simple Flask application that handles a form submission and file upload. A secret key is set for CSRF protection. The form is defined using Flask WTF with form fields for text input and file upload. The upload view function handles GET requests by presenting a form and POST requests by processing form data. Validate on submit checks if the form submission is valid and then saves the uploaded file securely to the uploads directory. The user is then redirected to a success page. Note that for this code to run, a corresponding upload.html template with a form needs to exist in the templates directory. Flask cookies and sessions. In Flask, cookies and sessions provide mechanisms to store information across requests. Cookies are small bits of data stored on the client side, which the server can set and retrieve on subsequent requests. Sessions allow for storing data between requests, but are typically server-side, with only a session ID stored on the client, enhancing security. The code demonstrates setting and retrieving cookies, and setting and getting session data in Flask. When accessing the set cookie route, a cookie named username with the value Flask is set. Accessing the root route reads this cookie. For sessions, the session route stores a username Flask in the session, and getSession retrieves it. The secret key is required for securely signing the session cookie. Django project setup and apps. Django is a high-level Python web framework that encourages rapid development and clean, pragmatic design. A Django project contains a collection of settings for an instance of Django, including database configuration, Django-specific options, and application-specific settings. The Django admin command is a command-line utility that comes with Django for administrative tasks. Start project followed by the project name, MySite, in this example, initializes a new Django project by creating the necessary directory structure. Once the project is created, you navigate into the project directory and use manage.py, a command-line utility, to create a new application within the project using startapp followed by the application name, myapp in this example. This sets up a new app with its own directory within the project that can contain models, views, templates, and more. Django models and ORM. Django models are the definitive source of information about your data. They contain the essential fields and behaviors of the data you're storing. Django follows the dry principle. The goal is to define your data model in one place and automatically derive things from it. Django provides an object relational mapper, ORM, to allow for the interaction with the database using Python code instead of SQL to create, retrieve, update, and delete records. In the provided code, we define a simple Django model named book. This model represents a book in a database schema. Char field is used for title, author, and genre, which are character fields with a defined max length. Date field is used for the published date to store dates. Boolean field is used for in stock to indicate whether the book is available. The default equals true means that by default, new books are considered to be in stock. When this model is migrated, Django's ORM will create a database table for it. Django templates and views. In Django, a view is a Python function that takes a web request and returns a web response. Templates are text files that define the structure or layout of a file, like an HTML page, with placeholders used to represent actual content. Django's template language allows us to display data in the context and use logic to control the flow of the template. In this code, we have a basic Django view called Hello World. This view uses the render function to create an HTTP response. The render function takes the request object, the path to the template file, helloworld.html, and a context dictionary. Here, we're passing a context dictionary with one key value pair, where name is the key and world is the value that will be used in the template to display dynamic content. Django forms and class-based views. Django forms are a powerful tool for handling user input in a web application. By defining a form class, you can create a form, validate data, and convert it into Python data types. In the code provided, we define a simple contact form using Django's built-in forms.form class. The contact form has two fields, name and message. In the associated view, contact view, we instantiate the form when handling a POST request, validating the data with form.isValid. If the form is not being submitted, we instantiate it without any data to display the empty form. The validated data is accessible through form.cleanDataDictionary after the form is validated. Django admin interface and deployment. The Django admin interface is a powerful automatic GUI for managing your Django models, and it's one of the most useful features of Django framework. This code snippet demonstrates Django's model registration with the admin interface. The @admin.register myModelDecorator is a shorthand for registering the model class myModel with the admin site. myModelAdmin class customizes the admin interface for myModel. List display allows you to specify which fields are displayed on the change list page of the admin for this object. Search fields specifies a list of field names on which searching is enabled. API development with Flask Django REST framework. Flask is a micro-web framework for Python, which is easy to use and can be scaled up to complex applications. Let's develop a simple API endpoint that returns a hello world message in JSON format. In the provided code, we import Flask and the JSONify function for creating JSON responses. We then create a new Flask application instance. We define a route/API/hello, which listens for GET requests. When this route is accessed, the hello world function gets called and returns a JSON response containing our hello world message. The JSONify function is used for automatically converting the dictionary to JSON format. The status code 200 signifies a successful HTTP request. Lastly, we run the application in debug mode so that Flask will reload itself on code changes. Introduction to testing. In software development, testing is a crucial process that involves verifying that a program operates correctly. Testing aims to catch bugs and ensure that the code meets its specifications and requirements. Testing can be manual, but it is often automated to enhance its effectiveness and efficiency. The provided code snippet is an example of a simple test case for a hypothetical addition function. The test checks if the operation 1 + 1 results in 2 using an assertion. If the test passes, nothing happens. However, if the test fails, meaning the addition doesn't give the expected result, the assert statement will raise an assertion error with the message, "The addition function is incorrect." This kind of test helps ensure that the basic functionality of the code is correct. Writing test cases with unit test. The unit test module in Python is used for encapsulating tests into test cases. It provides a rich set of tools for constructing and running tests, ensuring that code behaves as expected. To write test cases using unit test, you need to create a class derived from unit test, test case, then define methods that start with test to write individual test functions. Here's an example of how you can write a simple test case. The code defines a test suite as a class called testStringMethods that inherits from unittest.testCase. 3 test methods are defined. TestUpper checks if the upper method of a string returns the uppercase version correctly. TestIceUpper checks if IceUpper correctly identifies whether a string is uppercase. TestSplit checks that split divides a string into a list of words, and also that it raises a type error when a non-string separator is passed. Each test method uses assertions, like assert equal, assert true, and assert raises, to validate the behavior. If a test fails, an assertion error is raised with a descriptive message. In the main block, unittest.main is used to run the test suite when the script is executed directly. Test case execution. Test case execution is an important process in software testing. It involves running specific conditions or input combinations through the code and comparing the outcome to the expected result. This helps to determine whether your code behaves as intended under various conditions. Python offers numerous frameworks and tools such as UnitTest, PyTest, and DocTest to assist with test case execution. The provided code snippet defines 2 tests within a UnitTest test case class. The testSum method tests if the built-in sum function correctly adds up the numbers in a list. The testSumTuple method does the same for a tuple. The tests are run using the unittest.main function, which will execute all methods in the class that start with test. If a test fails, UnitTest reports the failure, indicating to the developer that there is a discrepancy between the expected result and the actual output. In this snippet, test_SumTuple will fail because the expected result is set as 6 instead of 5. Mock objects and monkey patching. Mock objects are used to simulate the behavior of real objects in a controlled way. They are particularly useful in unit testing, where you want to isolate the functionality of the component under test. By using mock objects, you can verify that the correct methods have been called with the expected parameters without relying on the implementation of external systems. In this code, unittest.mock.magicMock is used to create a mock object named service. A mock method service.method is assigned a return value of I am a mock response. When service.method is called with 42 as the argument, it returns the predefined mock response, which is then printed. Integration testing. Integration testing is a level of software testing where individual units are combined and tested as a group. The purpose of this level of testing is to expose faults in the interaction between integrated units. Here's a simple example using Python's unit test framework to perform integration testing on two functions that should work together. In this script, the add function adds two numbers, and the multiply function multiplies two numbers. The test integration class inherits from unittest.test case. It contains a test method, test add then multiply, which tests the integration of add and multiply by first adding 3 and 2, and then 1 and 4, and multiplying the two results together to check if the final result matches the expected outcome, 35. This ensures that the two functions correctly interact with each other. Launching the test using unittest.main will run the integration test. Debugging techniques. One of the simplest forms of debugging is to insert print statements in the code to display the values of variables and the flow of execution. In this example, a try-except block is used to catch a division by 0 error. The print statement within the except block is a simple debugging technique that provides immediate feedback on the error encountered. Profiling and optimizing. Profiling in Python is about measuring the resource usage of your code segments to identify bottlenecks or inefficient code parts. It helps in analyzing the frequency and duration of function calls. In the code provided, we've defined a function named mySlowFunction, which includes a regex pattern search inside a loop. Using the cprofile module from Python's standard library, we profile the execution of mySlowFunction. After running, cprofile will output detailed statistics about the function calls, sorted by the internal time spent. This information can lead us to understand the performance overhead and optimize accordingly. Static code analysis tools. Static code analysis tools automatically examine source code before it's executed to identify potential errors, style issues, or security vulnerabilities. In Python, popular tools include Pylint, Flake8, and MyPy. Here, we will look at a simple example using Pylint, which checks for errors, tries to enforce a coding standard, and looks for code smells. In the provided code, we define a function greet that takes a name parameter as a string and prints a greeting message. This is a simple example, but we can run Pylint on this code to perform a static analysis. Pylint would check for various issues, such as naming conventions, code complexity, and potential bugs. If there were any issues, Pylint would report them, along with a score indicating the code quality. Running static code analysis tools, such as Pylint, regularly helps maintain code quality and can help prevent issues before runtime. Introduction to scripting. In the context of computing, a script is a program written for a runtime environment that automates the execution of tasks which could alternatively be executed one by a human operator. Python is a popular scripting language due to its readable syntax and versatility. This Python script uses the OS module to interact with the operating system. The os.listDar function retrieves a list of entries in the current directory, denoted by. By iterating over this list with a for loop, the script prints the names of all files and directories in the current directory to the console. This is a simple example of how a Python script can be used to automate a routine task that would otherwise be tedious if done manually. Reading and writing CSV files. CSV, comma-separated values files are simple text files for storing tabular data. Python provides the CSV module, which allows you to read from and write to CSV files with ease. This module helps deal with various quoting styles, delimiters, line terminators, and more. The provided code has two parts, reading from and writing to a CSV file. While reading, a file object is created with openExample.csv, mode = R, and the CSV.reader is used to iterate over each row. In writing, openOutput.csv, mode new line = ensures no extra new lines are added on Windows, and CSV.writer is utilized to write rows of data. Note that Python's CSV implementation handles parsing and formatting of CSV files transparently. Automating file system operations. Automating file system operations is an essential skill if you need to interact with files and directories programmatically. Python's OS and util modules are particularly useful for this purpose, allowing you to perform operations such as creating directories, moving files, and changing the working directory in a script. The code snippet provided uses the OS module for automating common file system operations. It starts by importing the OS module, which provides a way of using operating system-dependent functionality. The os.path.exists method checks whether the example directory already exists to avoid an error when attempting to create it. If it doesn't exist, os.makeDirs creates the new directory. Then it moves example.txt from the current directory into example directory by using os.rename, which renames the file path or moves the file to the new path provided. Automating network tasks. Python can be used to automate a variety of network tasks, such as scanning networks, managing devices, configuring servers, and handling network protocols. The script below uses the Paramiko library, which enables SSH, secure shell connections to remote devices. With it, you can automate tasks on remote servers or network equipment that support SSH. This code creates an instance of SSH client from the Paramiko library, sets a policy to automatically accept the remote host's SSH key, and connects to the specified hostname using the given username and password. It then executes the ls command on the remote server, reads the output and error streams, closes the SSH connection, and prints out the results. To use this code, Paramiko must be installed. Pip install Paramiko, and the target server must have SSH enabled with the specified user credentials. Automating email sending. Python's SMTplib can be used to send emails using the Simple Mail Transfer Protocol, SMTP. To automate email sending, you typically need to set up an SMTP server, create a message, and then send it through the server. This is often used for notifications, reports, and batch job alerts. The code imports SMTplib and MIME-text to handle SMTP and email formatting, respectively. It sets SMTP server details and authentication credentials. The sender, receiver, subject, and body of the email are specified. A MIME-text object is created to hold the email contents. The email is sent using a with block to ensure the server connection is properly closed. Within the block, startTLS is called to secure the connection, login for authentication, and send message to send the email. Finally, the user receives a confirmation that the email has been sent. Scripting for image processing. Image processing in Python can be done using libraries such as Pillow, PLFork, OpenCV, or scikit-image that provide tools to manipulate images. Operations like cropping, resizing, filtering, converting between different image formats, or even more advanced transformations are available. Automation of these tasks is useful when dealing with large sets of images or when repetitive processing is required. Here, we'll use the Pillow library to perform a simple task: opening an image, applying a filter, and saving the result. The code imports the image and image filter modules from the Pillow library. It opens an image using image.open, which reads the file path to image.jb from the disk. The with statement ensures that the file is properly closed after its block is executed. The filter function is then used on the opened image to apply a blur effect, which creates a new image object. The modified image is saved to a new file, path to newimage.jpg, using the save method. The use of the with statement also handles the closure of the new image file. Scripting for PDF and document management. Scripting for PDF and document management involves using Python to automate tasks such as reading, creating, and modifying PDFs and other documents. This can save time and reduce errors in tasks that would otherwise be done manually. To work with PDFs in Python, the PyPDF2 library is commonly used, although there are others like PDFminer and ReportLab. The code demonstrates how to utilize the PyPDF2 library to open a PDF file and extract text from the first page. Firstly, we open the file in RB, read binary mode, which is necessary for PDF files. We then create a PDF file reader object and use it to get a page object representing the first page of the PDF. Finally, we call extract text on the page object to extract and print the text. Task scheduling with cron Linux and Task Scheduler Windows. Cron is a time-based job scheduler in Unix-like computer operating systems. Users that set up and maintain software environments use cron to schedule jobs to run periodically at fixed times, dates, or intervals. This cron job is scheduled to run the Python script located at /path/script.py every day at 5 a.m. Each asterisk corresponds to a unit of time: minute, hour, day of the month, day of the week. Placing a number in one of these positions specifies the time at which the cron job will run. Matplotlib basics. Matplotlib is a widely used Python library for creating 2D plots and graphics. It provides functions for creating a wide variety of static, animated, and interactive visualizations. In this basic introduction, we'll cover how to create a simple line chart to visualize data. The code snippet imports the Matplotlib library and sets up data points with lists x and y. The plt.plot function is called to create a line chart connecting the points defined in x and y. plt.title, pl.xLabel, and pl.yLabel are used to add a title and labels to the axes. Finally, pl.show displays the plot. This basic setup is a starting point for creating more complex visualizations. Advanced Matplotlib. Matplotlib offers extensive capabilities for customization to ensure that plots meet the specific needs and preferences of users. This can involve adjusting everything from colors and labels to scales and layout. This code snippet demonstrates some customization techniques with Matplotlib. A figure with a specific size is created using plt.figure, fig size 10:6. Then, a plot is generated with a predefined color, dark blue, line width, line 2, and a dashed line style core. The title, x-axis, and y-axis are labeled, and the grid is enabled for better visualization. Finally, pl.show displays the plot. Introduction to Seaborn. Seaborn is a Python data visualization library based on Matplotlib that provides a high-level interface for drawing attractive and informative statistical graphics. It is particularly suited for visualizing complex datasets and is built on top of Matplotlib, integrating closely with Pandas data structures. First, we import Seaborn and Matplotlib's pyplot module. We then load a built-in dataset called tips from Seaborn's repository. After that, we set the aesthetic style of the plots to white grid, which adds a grid and white background. Using barplot, we create a bar plot with day on the x-axis and total bill on the y-axis. Finally, we call pl.show to display the plot. This code snippet creates a bar chart displaying the average total bill for each day of the week from the tips dataset. Interactive visualizations with Plotly. Plotly is a popular Python library used for creating interactive visualizations. It is often praised for its quality of graphics and interactivity. Plotly graphs can be rendered in web browsers, allowing users to zoom, pan, and hover to see more details. We will demonstrate how to create a simple interactive scatterplot using Plotly. In the provided code snippet, we first import Plotly Express, which is a simplified interface to the Plotly library. We create two lists, x data containing sample x values, and y data, where each y is the square of the corresponding x. We then create an interactive scatterplot named fig, using the px.scatter function with labeled axes. Fig.show generates the visualization in a web browser, enabling user interaction with the plot. Geographical plotting with GeoPandas. GeoPandas is an open-source project that makes working with geospatial data in Python easier. It extends the data types used by pandas to allow spatial operations on geometric types. Geometric operations are performed by Shapely. GeoPandas also depends on Fiona for file access and Matplotlib for plotting. To plot geographical data, you first need to have a geodata frame, which is like a normal pandas data frame but with a column that contains geometries. The code imports GeoPandas and Matplotlib's pyplot module. It loads a built-in dataset, Natural Earth Low-Res, which contains country geometries from the Natural Earth dataset using the readFile method. Then it plots this data using the plot method on the world geodata frame. Finally, it displays the plot using plt.show. Note that the geometries in the dataset are what enable GeoPandas to plot the spatial data on a map. When the plot method is invoked on a geodata frame, it plots the geometries column by default. 3D plotting. 3D plotting in Python can be accomplished using the mplot3d toolkit that comes with the Matplotlib library. This allows us to create three-dimensional plots, which are useful for visualizing multi-dimensional data and mathematical functions. We use the axes3d object for creating 3D axes. The code begins by importing the required libraries, Matplotlib for plotting, and mplot3d for 3D plotting capabilities. We then create a figure object and add a subplot to it with projection equal 3D to indicate that it's a 3D plot. We generate x and y coordinates using np.linspace and create a mesh grid from these coordinates. which is necessary for 3D plotting. The z-coordinate is calculated using a mathematical function of x and y, in this case, a sine function. Finally, we use ax.plotSurface to plot the surface and display the plot with plt.show. This code results in a 3D surface plot visualizing the sine function over a grid. Visualization best practices. Selecting the appropriate chart type is critical for effectively communicating the data's message. The type of chart you choose should be tailored to the nature of the data and the story you want to tell. Use bar charts for comparisons, line charts to show trends over time, scatter plots to reveal relationships or distributions, and pie charts to show proportions of a whole. Introduction to machine learning concepts. Machine learning is a subset of artificial intelligence that involves the creation of algorithms that can modify themselves without human intervention to produce desired behaviors by feeding on data. A basic example to begin with is classification using scikit-learn, a powerful Python library for ML. In this code snippet, we use scikit-learn to load a dataset, split it into training and test sets, train a k-nearest neighbor classifier, and make predictions. The loadIris function loads a classic dataset with features of iris flowers. The data is then split into training and test sets with train, test, split. We create an instance of a k-nearest neighbors classifier with neighbors classifier, train it with the fit method on our training data, and make predictions on our test data with the predict method. This example encapsulates the basic workflow of machine learning in Python. Scikit-learn introduction. Scikit-learn is a powerful Python library for machine learning. It provides simple and efficient tools for data analysis and modeling. It is built on Numpy, SciPy, and Matplotlib, and it's easy to get started with machine learning tasks such as classification, regression, clustering, and dimensionality reduction. Scikit-learn, often referred to as sklearn, is an open-source machine learning library for Python. It features various algorithms like support vector machines, random forests, and k-nearest neighbors. It also includes tools for model fitting, data pre-processing, model selection and evaluation, and many more utilities. The library is designed to interoperate with the Python numerical and scientific libraries, Numpy and SciPy, making it a robust tool for data mining and data analysis. Supervised learning algorithms. Supervised learning is a type of machine learning approach that involves training a model on a labeled dataset. In this context, labeled means that each training example is paired with an output label. Given a new input, the trained model can predict the output based on the learning from the dataset. Two main types of supervised learning tasks are regression, where the output is continuous, and classification, where the output is discrete. The code provided demonstrates a simple linear regression task, which is one of the supervised learning algorithms. First, we import the necessary modules from sklearn. We then create a sample dataset with features x and target values y. Using train test split, we divide the dataset into training and testing sets. The linear regression model is instantiated and fitted with the training data using the fit method. After the model has learned from the training data, we use it to make predictions on the test set with the predict method. Finally, we evaluate the model's performance by calculating the mean squared error between the predicted and actual test values. Unsupervised learning algorithms. Unsupervised learning algorithms are used to find structure in data that doesn't have labeled responses. One of the most common unsupervised learning methods is clustering, where data is grouped into clusters. K-means is a popular clustering algorithm which partitions the data into k distinct clusters based on their features. The provided code imports the k-means class from the sklearn.cluster module and Numpy for numerical operations. A sample dataset X is created, which has two features. The data points are chosen to highlight how clusters might form. K-means is initialized with two clusters, n clusters equals 2, and then fitted to the data using the fit method. Once fitted, the labels attribute gives us the cluster assignment for each data point, and the cluster centers attribute provides the coordinates of the cluster centers. The print statements display the cluster labels and centers. This code showcases the core functionality of the k-means algorithm within unsupervised learning. Model evaluation and selection. In machine learning, model evaluation is critical for determining the performance of a model. The aim is to assess how well a model generalizes to new, unseen data. Evaluation metrics differ for regression and classification problems. Selection involves choosing the best model from a set of different models. To illustrate this, we will split data into training and test sets, train a simple model, and then evaluate its performance using accuracy as an example metric for a classification problem. Firstly, we import necessary modules, train test split for splitting the dataset, logistic regression as our example model, and accuracy score for evaluation. We assume a function loads sample data to provide features X and labels Y. We then split our dataset into training 80% and test 20% sets with train test split, ensuring reproducibility with a random state. After initializing a logistic regression model, we train it using the fit method on the training data. Subsequently, we use predict to make predictions on the test set. Lastly, we calculate the accuracy of our model by comparing predictions to the actual labels. Model serialization pickle joblib. Model serialization is the process of saving a trained machine learning model to a file so it can be used later without retraining. Python provides multiple ways to serialize objects, including pickle and joblib modules. Pickle is the standard way of serializing objects in Python, while joblib is optimized for handling large Numpy arrays more efficiently, making it more suitable for models that involve large data. The code performs serialization and deserialization of a trained logistic regression model using both pickle and joblib. The iris dataset is loaded and split into training and test sets. A logistic regression model is trained on the training data. The model is then serialized, saved to a file using pickle's dump method in WB, write binary mode. The same model is serialized again using joblib's dump method. Deserialization, loading the model from the file, is done using pickle's load method in RB, read binary mode for the pickle file, and joblib's load method for the joblib file. Feature engineering and pre-processing. Many machine learning models require numerical inputs and cannot handle categorical data directly. Hence, we need to encode categorical features into numerical values. One common method is using one-hot encoding, which creates a binary column for each category. In the code snippet, we use the one-hot encoder from scikit-learn to convert a list of color categories into a one-hot encoded numeric array. The sparse equals false argument makes the output array dense as opposed to a sparse matrix. The fit transform method learns the categories fit and then transforms the input data to their corresponding one-hot encoded vectors. Dimensionality reduction techniques. Principal component analysis, PCA, is a statistical procedure that uses an orthogonal transformation to convert a set of observations of possibly correlated variables into a set of values of linearly uncorrelated variables called principal components. Here we use PCA from the scikit-learn library to reduce the dimensionality of a dataset. The above code imports PCA from the scikit-learn library. We instantiate a PCA object, specifying the number of components, dimensions we want to reduce our data to, which is 2 in this case. The fit transform method fits the PCA model with the data X and applies the dimensionality reduction on X. The result is stored in XPCA, which now contains the transform data in the reduced dimension space. Hyperparameter tuning and grid search. In machine learning, hyperparameters are the configuration settings used to structure the learning algorithm. Unlike parameters, which are learned during training, hyperparameters are set before training and greatly influence the performance of the model. Hyperparameter tuning involves finding the optimal set of hyperparameters for a learning algorithm. Grid search is a method for tuning that exhaustively searches through a manually specified subset of the hyperparameter space of the learning algorithm. The code snippet below demonstrates how to use grid search with cross-validation to find the best hyperparameters for a support vector machine, SVM, classifier using the scikit-learn library. The code imports the grid search CV class from scikit-learn. This class is used to perform grid search on a set of hyperparameters specified in a dictionary, where keys are hyperparameters and values are lists of settings to try. Grid search CV performs cross-validation across the entire grid, all possible combinations of hyperparameter values, evaluates model performance for each combination, and retains the best combination based on cross-validation scores. Ensemble learning methods. Ensemble learning methods combine multiple machine learning models to improve the overall prediction performance. This can be achieved through methods like bagging, boosting, and stacking. An example of an ensemble method is the random forest algorithm, which combines multiple decision trees. In the provided code, we import the random forest classifier from Sklern's ensemble module. We create an instance of this classifier with 100 decision trees, n estimators equals 100, and a random state for reproducibility. We then train fit the classifier on the training set, xtrain, ytrain, and use it to predict labels for the test set, xtest. The result is stored in ypred. Neural networks with Keras TensorFlow. Neural networks are a series of algorithms that mimic the operations of a human brain to recognize relationships between vast amounts of data. They are used extensively in machine learning for tasks like image recognition, speech recognition, and many others. Keras is a high-level neural networks API that runs on top of TensorFlow, which is an open-source software library for data flow and differentiable programming. Keras makes it easier to build and train neural networks due to its user-friendly interface. This topic doesn't include code, as it's a high-level overview of neural networks and how Keras fits into the picture. Keras simplifies the process of creating neural networks by providing high-level building blocks. TensorFlow acts as the powerful engine that performs the heavy lifting of numerical computations required. Together, they allow for the efficient design, training, and deployment of machine learning models. Natural language processing with NLTK spacey. Natural language processing, NLP, refers to the field of linguistics and computer science concerned with the interactions between computers and human, natural languages. Python offers various libraries for NLP, with NLTK, Natural Language Toolkit, and spacey being two of the most popular ones. NLTK is ideal for linguistic research and teaching in NLP concepts, whereas spacey focuses on providing software for production usage. This example demonstrates basic text processing with NLTK and spacey. The code begins by importing the necessary modules from NLTK and spacey. It defines a sample text to work with. Using NLTK's word tokenize function, it tokenizes the sample text into individual words and punctuation. Subsequently, it loads spacey's English language model in Core Web SM to process the text. With spacey, the text is processed into a doc object, which is a sequence of token objects. Token attributes are accessed to create a list of tokens similar to NLTK. Finally, it prints out the tokens obtained from both NLTK and spacey for comparison. Understanding Internet networking. Internet networking involves connecting computers and devices across the globe via routers and servers, using a variety of protocols to communicate. The most fundamental of these is the Internet Protocol, IP. No specific code is provided for this concept, as it's a theoretical foundation. Internet networking relies on TCP/IP for data transfer, which ensures packets reach their destination reliably. Devices are identified by IP addresses, and domain names, translated via DNS, provide user-friendly addresses for resources. Protocols like HTTP, HTTPS, FTP, and SMTP define specific types of communication. TCP/IP model. The TCP/IP model, or Transmission Control Protocol Internet Protocol model, is a conceptual framework for understanding how different network protocols work together to enable internet and network communication. The model is divided into 4 layers: the link layer, the internet layer, the transport layer, and the application layer. The code snippet showcases a basic server setup using the socket library in Python, which implements TCP/IP protocol for communication. First, a socket object is created with AF-INET specifying the address family for IPv4 and SOCStream specifying the TCP protocol. Next, we bind the socket to a host import and start listening for incoming client connections. When a client connects, the server accepts the connection, sends a thank you message, and then closes the connection. This exemplifies the transport layer, TCP, and internet layer, IPv4, in the TCP/IP model, working with IP addresses and ports. IP addresses and ports are fundamental concepts in networking and are crucial for identifying devices and services within a network. An IP address is like a postal address for a computer, which allows it to be located on a network, while a port number is like an apartment number, specifying a particular service within the machine. In Python, you can use the built-in socket library to work with IP addresses and ports. In this code snippet, we use the socket module to retrieve the host name and IP address of the local machine. First, we import the socket module, which provides access to the BSD socket interface. Then, we call socket.getHostName to get the name of the local host. After that, we use socket.getHostByName with the local host name as an argument to obtain the corresponding IP address. The result is printed to the console, displaying the local host name and its IP address, creating TCP/IP clients and servers. The Transmission Control Protocol Internet Protocol (TCP/IP) is foundational for modern network communications. In Python, the socket library provides tools for creating TCP clients and servers. A TCP server listens for connections to a given IP and port, performs a handshake, then sends and receives data. A client initiates the connection to the server. The code consists of basic examples of a TCP server and client written in Python. The server creates a socket, binds to localhost on port 6789, and starts listening. It then accepts a connection, enters a loop to receive data, and sends it back, echoes. The client creates a socket, connects to the server, sends a message, receives the echo, and closes the connection. Both server and client use the socket library. The server uses bind, listen, and accept for connections handling, whereas the client uses connect to initiate a connection to the server. HTTP protocol and web communication. HTTP stands for Hypertext Transfer Protocol, and it is the foundation of data communication on the web. This protocol is used for transferring web resources such as HTML documents. Python provides several modules for interacting with HTTP services, one of which is ht.client for low-level HTTP communication, and requests for a higher-level, user-friendly approach. The provided code uses the requests module in Python to send an HTTP GET request to tpexample.com. It then prints out the response status code, which indicates the result of the request, the content type header, which specifies the media type of the resource, and the body of the response, which typically contains the HTML of the requested web page. FTP and SMTP protocols. FTP, File Transfer Protocol, is used for transferring files between a client and a server over the internet. Python provides the ftplib library to interact with FTP servers. The code establishes a connection to an FTP server at ftp.example.com, logs in with a specified username and password, lists the files in the current directory on the FTP server, and then closes the connection, working with APIs REST and SOAP. APIs, application programming interfaces, allow different software systems to communicate. REST, representational state transfer, and SOAP, simple object access protocol, are two different API communication protocols. REST is more lightweight, using standard HTTP methods, and it commonly exchanges data in JSON or XML format. SOAP, on the other hand, is a protocol that follows strict standards and usually exchanges data in XML format. Below is an example of a Python code snippet for making a REST API request using the requests library. The code imports the requests library, which simplifies making HTTP requests. A URL endpoint is defined for the REST API. A GET request is then made to the URL. If the response status code is 200, indicating success, the JSON data is processed using the JSON method. If the request is not successful, an error message is printed. This is a basic example of REST API interaction. The SOAP protocol would involve more complexity, typically requiring libraries such as Zeep in Python for creating and passing SOAP envelopes with XML data. WebSocket communication. WebSocket is a communication protocol that provides a full duplex communication channel over a single TCP connection. It is commonly used for real-time web applications, enabling the server to send messages to the client without the client having to request it. Below is a basic example of a WebSocket server and client in Python using the WebSockets library. The above code sets up a simple WebSocket server that listens for incoming connections on localhost and port 8765. The echo function is an asynchronous generator that waits for a message from the client. When a message is received, it's sent back to the client using a waitWebSocket.send message. To run this server, the WebSockets.serve function is called with echo as the handler, and it is scheduled in the event loop, which is then run indefinitely with asyncio.getEventLoop, run forever, SSH, and remote script execution. SSH stands for Secure Shell and is a protocol used to securely connect to a remote server. To execute scripts remotely over SSH in Python, we can use the Paramico library, which provides an interface for working with SSH. To do this, we'll establish an SSH connection, authenticate, and then execute our commands or scripts remotely. Below is an example of how one might execute a simple command, ls-l, on a remote server. The provided code uses the Paramico SSH client to establish a connection with the remote server using client.connect. It uses a hostname, username, and password for authentication. Note that key-based authentication is more secure. Once connected, it calls client.exec command, passing the command to execute. The method returns 3 file-like objects, stdin, stdout, and stdair, for input to and output error from the remote command. The stdout.read method reads the command output, decodes it from bytes to a string, and prints it. After executing the command, the connection is closed with client.close to ensure resources are freed.
Okay, well, thank you for watching. So this was the entire live stream, and our website is now fully constructed. You can go back to any chapter and review, just like this. But now that we are done with the website creation, the streaming, we have generated, we are done with the code, and the Python course folder was generated, index and the course material is moved here. So now I'd like to show how we can deploy it, as you see now, because this is running off of a local server. So you can use any hosting platform you like. I like Railway, but you can use Heroku, Render, or even AWS. I'm just going to go to my Railway. I have a Railway account and my GitHub is already connected. Just going to go to my dashboard and I'm going to say new project so that we can deploy it just like we have done here. I'm going to actually update this course, but I'm going to show you how the process works. Just go to new project and I'm going to type in for Nginx, which is for a static website. Once I select that, and it has connectivity to my GitHub, it's asking for a repository name. I can say Python course live stream. Just as a demonstration, I'm going to make this a private repository. I'm going to say deploy. Now, Railway is actually creating this repository. We can actually go to my GitHub and check. I can search for Python and Python course live stream was created. Okay, so all I have to do is just copy the index.html and the course folder here, and this website will be deployed. Its default address will be this, but you can actually change it. Public networking, you can actually rename it. And if you have a custom domain name, like a .com or something, you can link it, right? So this is how it works, but I already have one deployed, so I'm just going to go to Learn Python Fast, which is this website, and I'm just instead going to update it. I believe this one uses, let me find this real quick. Go back to my repositories. And search for Python course. And all I have to do is update the site, right? It already is my index.html. And I'll have to upload the course material. I can actually delete this directory. Commit the changes, and when I upload the index.html, this is going to get overwritten. But before I do that, I want to make some modifications to my HTML. What I mean is, currently, this is how it looks like. I just want to change this title. You can do that, right? And I want to change this footer text. And for this, I'm going to go to the Python courses index.html, and I'm just going to change this to this website was created by AutoStreamer. I'm just going to say that. And when I do this, because we are running this currently with live server, this should update. Oh, we are actually, yeah. Because we updated this index.html in Python course and we were streaming off of this index, so I'm just going to live serve this one so I can see the changes in real time. Yeah, there we go. This website was created with AutoStreamer, and I also want to point people to the AutoStreamer's website, and I have that div right here, I believe. And I'm just going to copy this to the appropriate spot. It should be right here. Let me double check that this worked. Yeah, say download AutoStream. Oh, right here. Let me double check. Oh, I haven't copied the right one. Yeah, I wanted this one. Sorry about that. Paste it here. And now it should, yeah. So now it's clickable and it takes you to the AutoStreamer's website. So this is good. So now I'll go back to my website. GitHub. I'm going to go add file, upload files. And I'm first going to upload the Python course index.html. Let me just do this first. Because I'll show you, because when you can't upload any more than 100 files at the same time, and this has 191 files. I'm just going to see if I can actually create a folder here. It doesn't let me. So if I try to copy the course folder as it is, it's going to say that you can't upload more than 100 files. So what I'm going to do is go to the bottom of this and select 100 of it. 53 items. So this is a bit of kind of guesswork. But if I come to 108, okay, I've selected 99. I'm going to cut this and paste it here. So this course folder now has less than 99. I can now go ahead and upload files here. This probably, I should do this with git pull and push, but here we go. It's uploading these 99 files. After that, I'm just going to go inside that directory and I'm going to upload the rest of it. And when this is working, if I go back to my, where is it? Railway. When it updates, this is actually going to redeploy once I commit, that is. So we'll upload these, commit. I'll show you that it's redeploying. And after that, we'll upload the rest of the files. Yeah, this is probably much better if you do it with git pull and push and with git commands. Okay, this is just going to take a second. When this commit is done, since this site is connected to that repository, this should update, unless I'm making a mistake, but I don't think I am. Okay, yeah, see how it is redeploying, but we're going to upload the rest of it. So I'm going to go to site and course, and I want to upload the rest of the files that I have here. I'm just going to cut them select all of them, and first drag them here. This was the rest of the content and audio files for this website. But we can actually see here that this already is deployed. So if I go back to Learn Python Fast and refresh, we should actually see once it refreshes. This can take 30-40 seconds for it to update. We can see it reflect, but we'll just wait because we need to do this anyway. If you didn't have so many files, like you would just upload it and you're done. It's really not that difficult of a process. Okay, they're uploaded. I'm gonna commit changes. So this is gonna process. Railway is gonna redeploy our project. And thank you for watching, by the way. Like I said, AutoStreamer version 2 is available at my Patreon. If you have any questions, you can feel free to ask me at Discord. Link to both is in the description. So once this processes, we can go back to Railway and it's going to redeploy. And as you can see, our URL is learnpythonfast.app.railway.app. But if you had a custom domain, we could have assigned it to it. We can also change this. I just named it Learn Python Fast. But anyway, once this deploys, this should also work. Yeah, it's currently available for $200. This is the website. It's not the most beautiful website, but I'm still working on it. Let me close all this. So we're done with GitHub at this point. We're just waiting Railway to deploy. So it deployed. So now we can click here. And see, it isn't yet still updated. So this takes a couple of minutes. You can review your logs to make sure there's no problems, which there shouldn't be. But this is how it works, really. It's a full website. And it's usable. I hope I didn't upload it to the wrong repository. I don't think so. Yeah, Radoslav, currently the way it works is, I mean, as you see, there's quite a lot of code that goes to synchronize everything. I mean, to have a additional extended explanation is definitely possible. If you do decide to download, you can actually modify the code to do that. I just kind of did it this way. I'm going to be still working on it. But more or less, this is how you deploy. Yeah, I think it sometimes takes a minute to update. I think that's our problem. So, but the bottom line is you're at Railway, you create a new project, select Nginx, or the template for a static site. Then you enter a repository name, it'll create it. And then what you need to do is replace the index.html and upload the course files. And this will create the course like this right here. Well, thanks for watching. One more question. Can we communicate directly on Discord once this webinar is finished? I have an advanced idea about editing live JS, for instance. Yeah, you can message me, but I mean, if it is, I'm usually very busy, but if it's related to questions about AutoStreamer, sure. If you have general questions, you can message me. If I have time, I'll try to respond. You can also post it in the Discord channels. There are over 1,000 people there. They're all like to talk about this type of stuff. So yeah, it's totally up to you. Yeah, feel free to do that. Well, thank you for watching. And I'll see you. I'll try to make AutoStreamer stream other concepts. So I've done calculus and Numpy. They're a lot of fun. Even it does a pretty good job with even standard Python libraries. You get to learn a lot. But yeah, and if you enjoy my content, make sure to check out echohive.live. You can find my content easily there. And if you're a patron, you can find the code download links. Other than that, take care. Have a great week. And see you in the next live stream or the video. Take care, everyone. Take care, Radoslav.